business.
So I understood this talk will be recorded, and I guess it will be then on YouTube or something, so that I find it and can link to it.
Yeah, sure. So you agree it's going to be recorded, right?
Yeah, that's fine. Somewhere I agreed. I don't remember, but
yeah, you told me. Yeah.
Okay. Yeah.
Okay. This session is recorded now. They are saying.
Okay, so okay. Yeah. Good.
Hi, everybody.
Hi.
Hi, Corpo.
Hi, everyone. Hi, Sven.
Hello.
Hi,
Sorry, Andre.
Hello, Samuel.
Hi.
Morning, all.
Hello, Andrea. How you doing?
Very well, thanks, Alberto.
Yeah, I was saying hi to two people.
I think we even have three
Hi,
Andres.
Alberto. Hi, Alberto.
To Andre.
Yeah, Andre Bauer also.
That's efficiency.
That's the broadcast. Yes.
Exactly.
It's kind of a rare name here, and we had two Andres in my office in Princeton a long time ago. It was just a running joke. We'd say, "Morning, Andre. Morning, Andre."
So Jack is connected too, right? Oh yeah, I see you.
Oh yeah, yeah. Sorry, I thought that you were talking about someone else. Since people are talking about Andre.
Hello, everyone. So quiet.
We're waiting for people to join.
So just curious, you know, for the keynote tomorrow and maybe on Friday, like during this period, is it a good idea to just play some sponsorship videos or something just to kind of fulfill our promises?
You mean as part of the keynote announcement or during?
No,
after
no,
the
right now,
keynote?
as
Please,
we're just
not
filling
during
up
the
the
keynote.
as we're just filling up the blank, because I think some people just hate silence, right? So we just kind of
Yes.
have.
Yeah, I mean, at some point, if you have promised to have some kind of
We'll
motion.
display the slide and we'll display the slide with the sponsor. I think during
Yes.
the break, I think it's a good idea.
I think that's good.
Yeah, I'm thinking of this as virtual tea right now.
It's actual tea. Ah, there we go. Actual tea.
Prost.
Ooh, that is a delightful tea. So I am sure, if nothing else, my the quality of my tea during the conference is higher for being a remote conference.
There are advantages.
There must be some advantages, right?
No, no.
So we may be waiting 5 more minutes for people to take the time to connect. There are 56, 57 participants right now.
For some reason, opening session has always been not very well attended in physical and also in virtual format. For some reason, I don't know. In physical format, people are walking around the hotel. I don't know.
No, but in this case, Sam, Joanne has placed 2 good Swedish outside, you know, before. And there are Swedish and good stuff outside. So people are all there, you know, waiting, I mean, eating and doing things. That's the problem.
It's
But Sam, just to verify, once the opening session is over, they move to Keynote, there will be much more people, right?
Yes.
We want to have some, okay.
Suggestion in the future, we just write Keynote. We don't write opening session, and we make it longer, 15 minutes longer in the beginning of the opening session.
Yeah.
So we stay in the same room. What did you say?
Yeah.
Yes.
Yeah.
Yeah, actually, I was looking for the Slack channel Keynote for some time. And then
there is the Slack channel Keynote's been happen, and it points exactly to the same Zoom room.
okay, I didn't find that, so I'm too old for this. I fear.
first session.
If you are old, what about me?
Young at heart. Sorry.
The whole day is going to be here, or you have parallel sessions?
No, there's only one session.
Yeah.
Okay.
Everything will be here, but we use different session on the Slack for the questions and interaction. It's simpler, I think. And Jack will explain to everyone how to join the channel if you didn't find them.
Okay.
Because part of the opening is to explain how it's going to happen.
Yeah, I found the intro session channel. I didn't find the Keynote channel yet.
Yeah, me neither. Yeah, but
Probably should browse channel again.
Exactly, browse channels. I just browse them.
If you browse channel, they should appear and you can join.
Ah, okay.
It
You
might
can
be
also
worth an
search.
announcement of those in general, because I think everybody's in general. Oh, there's intro session.
Yeah. Yeah, the intro session is a channel from last year that we kept, and we linked to the Zoom channel, to the Zoom room right now.
Yeah, I almost went to last year's Zoom link.
yeah.
All the Slack roads leads here. So
all roads lead to Rome.
yeah, exactly. All Slack roads today they lead here. So no problem.
Everything leads to L'Aquila now.
No. Here, I mean, in this, no, not in this case, Albert. I'm sorry.
I missed the Amiternum bus stop, which had the bus to Rome, for those of you who haven't been to L'Aquila.
So maybe we will start.
There are still people entering. I mean, but yeah.
I think we booked 30 minutes for the welcoming, while we need actually 15, I think, maximum. So
I could use another 5 minutes. So
you always underestimate how much you need.
I think we can just go ahead.
Yeah,
it's like in a physical conference. People
will come.
Will enter meanwhile. Okay.
So there's 70 participants, so we can start. So I will start. So I'm really happy to welcome all of you to the Icpe 2021 conference in Rennes. Together with Jack, Vittorio, and Corporal, we are really happy to welcome you. So while doing this welcoming session slide, we were wondering what we promised last year during the closing of the Icpe 2020. So what we promised you was something like this. So we promised you to come to Rennes, a beautiful French city on the northwest parts of France, with this interesting buildings, these nice amphitheaters, and a gala dinner at a very old place that was recently restored, and that is quite amazing to have a dinner there. And as you know, unfortunately, this will not happen exactly like this. And we will mainly use these three software that brings us together, even if we are not in the same place. So we will mainly use Slack, as you probably already know, Zoom, as we are talking now, and YouTube for the pre-recorded videos, and for distributed, for publishing later what we have recorded, if everybody agrees. So later, Jack will explain you exactly how these three tools will work together at the end of this opening. A few words about the registration. So as you know, for participants, the registration is free. So we have a quite high number of registered participants. So this morning it was 466. And what is worth noting is that we have 267 academics registrations and almost 200 industry registrations, which make approximately 57% and 43%, which is probably a little bit different from what we usually have, which is more 70-30. So I think it's something interesting to note. We have 369 registrations for the main conference, and I've made some very quick statistics about the workshop participation during the Zoom session. And if you average among all the workshops and tutorials, and you take all the unique connections that last more than 10 minutes to each workshop, you reach the number of 50 average for all the workshop. So this is in some numbers. I would really like to thank the organization team. So here are numbers of photos of people that participate in the organization team. So high five to everyone. Really, you did a great job. It was not so easy because we planned it initially as a physical conference, and we moved to a virtual one, and everybody was on board and everybody helped as much as they can. So thank you to everybody, and let's enjoy the conference now. I also want to thank the supporters, so ACM, the SIGmetrics group, and the SIGSoft group, and the Spec research group, which are a long-time support for the Icpe conference. I would also really like to thank our gold sponsor, Huawei, this year, because thanks to the sponsorships and the effort of all the organization committee, we are able to make the conference free for the participants, which is, I think, a very, very good thing. We also want to thank the workshop organizer And the workshop that has been taking place the 2 previous days was really, really interesting. The tutorials too, there were some interesting attentions to all these tutorials. And of course, the conference is nothing without paper authors. So thank you to everybody and also to the reviewers, but Corporal will talk about this later. And obviously, thanks to all the participants that are listening now. And now I will hand the floor to Corporal to talk about the program.
Thank you, Johan. So, as you all know, we have a little bit of a pandemic going on. Despite that, we still got 79 submissions to Icpe, which is pretty good considering all the circumstances. So we have several tracks. So like always, we have the main research papers track, industry and experience track, the work in progress track, and demo and poster track, and a tutorial track. So we had 43 submissions to the main research papers track this year, of which 12 were accepted and 8 were accepted as short paper. So this comes down to an acceptance rate of 28% for the full papers. For the industry track, we had 18 submissions, which was pretty high compared to the previous years, which 4 were accepted and 3 as short as a short paper, which comes down to an acceptance rate of 22% for full papers. Then we had the work in progress and the vision track, in which you can submit upcoming work or work that's not completely been evaluated yet. So there were 11 submissions, 4 of which were accepted. So that's a 36% acceptance rate. Then we had 5 submissions for demos and posters, of which 4 were accepted. And we had two tutorials, of which 2 were accepted as well. So Johan, can you go to the next slide, please? Thank you. So this whole process was not possible without all the help from all the PC members. So we had, over all the tracks, we had 234 reviews by 93 program committee members. So thank you so much for helping out. So we would also like to recognize the best reviewers, and this will be done during the social event on Thursday. So if you look into the program, this is after the poster session. So please come there to have a chat with your friends, to meet new people, but also to learn who are recognized as the best reviewers. Thank you. So just a brief overview of the program. So we're in the intro session right now. So after this, we will probably have a short break and then move to the keynote from Professor Appel from Saarland University. Then we have paper sessions on testing, measurement, and profiling, and a work in progress and the vision session today. Also, we have the Kaivalia Dixit Thesis Award winner. So the winner, so this is a competition where the best thesis on performance from the last year is awarded. So this is a prestigious award, and I highly encourage you all to come there and look at what the thesis is about. Yeah, thank you. And also at the end of today, there is the Icpe steering committee meeting. So it's in the program on the website. If you want to join this, then please contact me on Slack and I will give you the Zoom information. Okay, so tomorrow we will start with a keynote from Professor Liu from the University of Chicago. And then we will have paper sessions on modeling and optimization, memory and resource management. And we will have a poster and demo session. We will also have a session in which SPEC is introduced. So if you do not understand what SPEC is about or you want to learn more about it, then come there, because David Reiner and Sam Kunev from SPEC and the SPEC research group will give an introduction to SPEC and the research group there. Tomorrow we will also have, like I said, the virtual social event. And there's also the award ceremony. So it's a good chance to catch up with some friends, make some new friends, and to find out who are the awards. Because we will have best reviewer awards, but we will also have a best paper award. And I will talk a bit more about this in one of the next slides. So Johan, can you go to the next one, please? Thank you. And on Friday, it's already the last day of Icpe. So then we will start with the most influential paper award. So there was an award committee that selected the paper that was published at ICPE 10 years ago, which has had the most influence on research and the biggest impact on also on society or the performance engineering community. So that award will be presented on Friday morning. And then we will have 3 paper sessions, one on service-based systems, one on benchmarking, and one on IoT, embedded systems, and cloud. And then we have the closing session, in which also ICPE 2022 will be announced. So we have 3 best paper candidates. Of course, I encourage you to look at all the paper presentations, but these, make sure not to miss these 3 in particular. So the first best paper candidate is a multivariate characterization and detection of software performance anti-patterns by Alberto Avritzer, Riccardo Brito, Katja Trubiani, Barbara Russo, Andrea Janes, Matteo Camilli, André van Horn, Robert Heinrich, Martina Rapp, and Jörg Hens. So this one will be presented and discussed during session 3. Then the second best paper candidate is compositional evaluation of stochastic workflows for response time analysis of composite web services by Laura Cannavali, Riccardo Reali, and Enrico Vicario. And this one will be discussed and presented during session 5. And the third best paper candidate is by Günther Hesse, Christoph Mattis, Michael Perscheid, Matthias Uflacker, and Hasso Plattner. And it's paper titled ESP Bench, the Enterprise String Processing Benchmark. And this one will be presented and discussed during session 6. So congratulations to these nominees. And like I said, don't make sure not to miss the award session on Thursday during the social event. Okay, so we have 2 exciting keynotes. So the first one today is by Professor Sven Appel from Saarland University on software performance modeling in space-time. And the second keynote is tomorrow by Professor Liu from University of Chicago on tackling performance bugs in web applications and cloud systems. So make sure not to miss these keynotes. I'm looking very much forward to them. Thank you, and then I hand the floor over to Jack.
Okay, thanks, Kopo. So I'm here going to talk about the conference organization. So before I start, I would like to kind of say thank you for the previous ICPE organizers, especially the ICPE organizers from last year, who kind of did the first time kind of virtual conference setup. So we kind of learned and actually even reused quite a bit from the setup from the previous year. So one of the things I would like to say is we decided intentionally to reuse the Slack workspace, which will be the primary place where all the ICPE participants will kind of socialize and communicate and talk to each other. So the decision is being because there are quite a bit of registered people from last year. So we would like to kind of continuously kind of grow and nurture this kind of virtual ICPE community. So that's the reason why we kind of reuse the Slack channel from last year and kind of build on top of it for this year's Slack channel. So again, consider this as a main place where you can kind of socialize, talk to people, and asking for various kind of questions. On top of that, all these Zoom links will be posted on the Slack channel as well. So the general setup for the Slack channel is we're going to have 1 Slack channel per session. So for example, currently we're having the intro session. So there will be 1 Slack channel, and there will be followed by the keynote channel, as well as a particular paper sessions one as well. So again, we have posted quite a bit document on the Slack channel. So please go through and check it. In particular, I would direct you to read the kind of virtual ICPE guidelines posted on the guideline channel. So to kind of give you kind of a general feeling of various kind of things to do and not to do, as well as what kind of tools and things you can leverage on. Next slide, please. So in particular, one of the things I would like to point out is because I would assume many of you guys are actually the first time kind of using Slack. So I need to kind of at least show like one particular thing which kind of bugs me for a little bit before I seek help from, Kopo and Johan, which is, there actually we have quite a bit of Slack channels set up for this particular conference. So when you log in, it's only showing you a small portion of it. So if you need to actually get more or search for a particular channel, so go to that particular channel thing and click the 3 vertical dots, and it will show you that particular menu item called Browse Channels. So once you click that, it will actually show you the complete list of all the Slack channel for this conference. So this is just a FYI in case you did not find the kind of channel topics for the ones you are looking for, like for an individual session or for the keynote. So next slide, please. So again, as Johan said, I need to talk about the virtual tools. So this is basically a very, very high level kind of introduction. So first thing is for all the presentation stuff, the videos are already uploaded and available on the Icpe YouTube channel. So please go and check it out if you have not done so. And the second thing is for all these talks, including the keynote and so on, those will be conducted on the Zooms. And the Zoom links are posted on the Slack channel as well. So one thing I would like to point out is since the Icpe main conference, I intentionally set up to be only one track. So it will be the same Zoom link throughout the main conference. So, but just for convenience, we'll also kind of copy and paste this particular Zoom link and the individual kind of Slack channel for different sessions as well, just for your convenience. But just be aware, it will be just the same Zoom link throughout. And again, we're also going to have coffee breaks and social event, but it's more about, coffee break on us, but, bring the coffee and cake and tea by yourself. So for these things, again, it will be also posted on the Slack channel, and you feel free to also participate and discuss on the Slack channel. And for the Zoom links, we're also going to be created for breakout rooms and the link for the corresponding Slack channel as well. So this particularly apply for the things like posters and demo session and so on. And another thing I would like to point out is the award session will be announced again. It's also a virtual event during the social evening, a social event during the Thursday in the evening time. Next slide, please. So again, so there will be a more detailed announcement during the closing session of this conference from the actual Icpe 2022 organization committee. But here is just a brief announcement. So in case you guys are wondering about where Icpe will be next year, so it will be targeted to be held in Beijing, China. But again, the more information will be announced again in the Icpe 2021 closing session. So please stay tuned if you want to know more about what's going to happen for next year. Next slide, please. So again, in the end, on behalf of the whole organization committee, I would like to welcome you to the virtual Icpe 2021. Again, all of us are here. So if you have any questions or concerns, please kind of talk to us, message us on the Slack channel. And we sincerely hope you all enjoyed the conference. So I hand over the floor to Victoria to kind of start introducing the keynote speakers.
Okay. Thank you, Jack. Thanks, everybody. I will be the chair of the first session of this year, which is dedicated to the first keynote. So first, I would like to thank all of you to be attending this session. We are 93 at the moment. So I thank you for not being lost between the tools, Slack and other places, but you are in the right place now. So good. And also, I think you are in the right place because you didn't want to miss the first keynote that is held where the speaker is in the middle of countryside with such a great scenario behind him. So I think historically, even the COVID and the pandemic event has brought us some news, you know, like attending a keynote with such a scenario. So I think you didn't want to miss it. It is my great pleasure to introduce Professor Sven Appel. I know him since quite many years. He is chair of software engineering at Saarland University now. He got PhD in 2007 in Magdeburg, and his research interests are mainly in software product lines, in feature and aspects, but with a special attention to performance. He has been publishing several papers on performance aspects of software product line, and then analysis, optimization, and evolution. Probably many of you know him. You know that he has published more than 250 publications with several awards. In particular, I want to outline 2 awards at the Icpe conference in 2015 and 2021 for the Distinguished Best Paper Award. And he's regularly member of program committees of major conferences in software engineering like ACA, SE, Icpe, and ESEC FSC. He's member of editorial boards of IEEE TSC, IEEE Software and Empirical Software Engineering, and he's involved in several research projects. And I can witness that he is the chair of a great research group that I had. I was lucky to visit a couple of 3 years ago, I think, and it's a great, very active research group. Also, today is a special day for him, but we will talk about this later after the talk. So thank you for being here, Sven. And he will be talking about software performance modeling in space-time. Please, if you have questions, you can type on this chat, or you can type your question on a dedicated channel, which is Keynote Sven Appel channel. So you can type questions on both places, and we will arrange discussion later. So please, Sven, the stage is yours. Thank you very much.
Thanks a lot. That was very kind. Can you see my screen?
Yes, we can.
Okay. Thanks a lot. Yeah, so very kind, Vittorio. So I'm very happy that you invited me to talk about my research. I think it's fair to say that I'm from a bit different community than Icpe, but I think there's lots of overlap, and there's also many things we can share and learn from each other, right? And I think that's a very good opportunity. So today I'm talking about our work in that direction, and of course it's interesting also to hear what you think about that and so on. So maybe we can also get inspiration from you and the other way around. So yeah, I'm talking about software performance, of course, modeling in space-time. And I think it will be clear shortly what that means. First, very important, that's the team effort. So I listed a few colleagues and students here that were directly involved in the results I present here. And that's very important to acknowledge them, yeah, from different institutions. So the term space-time, it's a bit catchy, I admit. So it's from physics, right? Space-time fuses the 3 dimensions of space and the 1 dimension of time into a single 4-dimensional manifold. And in our setting, so that's basically an analogy in our setting. When we talk about space, we talk about the configuration space. And when we talk about time, then we talk about the evolution of a software project or software system along its revisions. Okay, so first, space, so configuration spaces. So our group and our community is interested in software configuration. For example, when you compile the Linux kernel, you can choose among 13,000 configuration options to tailor it to your use case and your hardware platform. You can tailor your operating system distribution. You can also tailor and customize individual programs like SSH, so you can set command line configuration options and so on. And basically, it's very hard to imagine any complex or sufficiently complicated or complex program that is not configurable. So configurable software systems, that's not a niche problem, right? So most systems are really configurable. So here in this talk, we are not interested in specific configuration mechanisms, languages, and tools. So we take this bird's eye view, which can be explained with this equalizer, music equalizer. So you have these switches where you can switch certain features on and off. So you want encryption or not in your system. And you have these sliders, which correspond then to numeric configuration options. For example, the cache size in a system is a numeric value from a certain range. And the basic question that pops up everywhere is in different variants, of course, which configuration is best, right? And with best or good, we can mean many different things: secure, safe, reliable, fast, efficient, etc. Right? So anything that is kind of measurable and of interest. And the first question, and when we started with that, it was clear but not really researched, at least in our community, is does it make a difference for performance? So is configuration really changing performance substantially? And thanks to Puyan, we have these nice plots here that illustrate this. For example, for Apache Storm, at a certain setting, of course, the throughput between the worst variant and the best variant, or the worst configuration, the best configuration is really substantial, right? 480 times. So it really makes obviously a difference. And the other important thing is that it's typically very difficult to conclude from setting individual configuration options through the overall performance behavior. So if you look at this picture here, on the y-axis, you have latency as the property of interest, and then you have the settings of two configuration options: number of splitters, numbers of counters. And what you see is that that's a non-trivial manifold, if you want, right? So a non-trivial performance landscape. So it's not sufficient just to know and test and try individual configuration options. They apparently make a difference also when being combined, right? And that's actually bad news, because in order, for example, to learn which is the best configuration for my case, it's hard really to find it just by looking at individual configuration options. So actually you need to really, in the worst case, you really need to try all of them. That's unavoidable. If that's always necessary, is the other thing, but in the worst case, you need to try all of them. And then in our community, we have always this nice slide here, this nice example. SQLite has a database system that most of you have on your phone, has 88 compile time configuration options. So which is fastest with regard to a certain workload? Well, if you really want to try all, and I think you know what an exponential problem is, you would need to start at the Big Bang, and you would not be done until today, ICPE, but only after a very long time. And that's just to illustrate this, that it's really infeasible in every case. So you get the results far too late, even if you have less configuration options. So what are people doing in academia and in practice? Well, you need to do sampling, configuration sampling. You need to select a few configurations with the goal of making informed statements about other configurations, right? And the interesting thing here is that in our community, many different sampling strategies have been developed. And the point is that there are constraints among configuration options or settings of configuration options. That's typically not the case if you look in a standard machine learning book, right? So for example, the Linux kernel, if written down as a propositional formula, has 300,000 clauses describing constraints among these 13,000 configuration options. Yeah? And there, well, you can count them differently, then it's just 200,000. The point is it's really complicated. And even random sampling, uniform random sampling, as people do in machine learning all the time, is very difficult and even an NP-hard problem. Yeah? So that's why there are these heuristics out. So that's a thing that is special in configurable systems. Then, of course, based on a sample, you would like to do predictive modeling, right? Or you can also call it machine learning. And there are many standard techniques out there. Important thing is that typically you are data sparse in the setting, so it's not a good case for deep learning, but more for the standard kinds of techniques, like some forms of linear regression. Yeah. And what is interesting here again, and I will show a little some results later, is that the question whether there's an interaction between the different sampling strategies and the different learning strategies. And if you think about this, there might be an interesting connection. I will talk about this. Yeah, well, and then the goal is, and it was a bit simplistic in the beginning, is not just knowing which is the fastest or best configuration, but you would like to understand the performance landscape in terms of a model. Yeah, and depending on the modeling technique, you have these models are of different form, and then you can talk about which model is really understandable, because we want to, of course, give the model to the optimizer, but also to the programmer, and that's to the programmer. That's especially important in our research. So we are interested in the interaction between the performance model and the programmer. So it's actually a comprehension problem that's going on here. So that's maybe a bit abstract. For those who didn't do that, a very simple approach is just to use linear regression, right? So in linear regression, you try to relate a dependent variable, which is in our case a property of interest, like throughput or execution time, and the number of so that's a dependent variable and the number of independent variables. In our settings, these correspond to the features or configuration options, right? And what you would like to do in a learning / optimization step is to identify the influences. The magnitude these individual features influence the overall property. And these predictions you can get out of this may not be correct. So there's also an error involved, right? Pretty simple and standard statistics 101. So problem is, and everybody of you knows that certainly performance is nonlinear. So it can be illustrated very nicely with X264 as a video encoder. So if you run this command line program with a couple of parameters, command line options, and on a certain video file, then you get a certain execution time, right? Just 600 something seconds. So now you can also use different configuration options. You can additionally enable the quiet option, whatever it does, and it is faster, right? You could also do another try with just enabling the no ASM option. It's again a different time. And now non-linearity in this case means that basically the time you need when enabling both options at the same time, so quiet and no ASM, is non-trivially related to the individual times of just selecting quiet standalone and no ASM quiet alone. So basically they don't add up, right? It does not necessarily need to be addition, but in this case, that's the right operation. Yeah, so that means I cannot just measure these variants with these individual options enabled, but I need to also look into the combination. Yeah, so that means for our regression problem, so that we need variables for features, but also for feature interactions, right? Because otherwise the learning procedure cannot learn these combined influences. Right, so at least in the case of linear regression. So that means either we include variables that correspond to interactions, or I add these multiplicative terms that play the same role. Yeah. Problem is, okay, if I just include pairs of features, I have a quadratic number of additional variables. And if I look at all kinds of orders of interactions, also triple-wise interactions and so on, it's an exponential number. So what do you do here? So in our early work that started in 2011, 12, and so on, so we used feature selection. Even at this point, we didn't know what it is because machine learning was not yet so mainstream. So the point is that you need heuristics for which features to select. So you do forward feature selections. So you start with low orders of interactions. You assume a certain hierarchical relationship between feature combinations, and you do symbolic regressions. So basically trying, maybe based on domain knowledge, different kinds of functions and see whether the error gets down, right? So that's very interesting. That sounds, now as I think about it, sounds pretty straightforward, right? When we did this in 2011, many people we talked to in the software engineering community, I have to say, that's not possible. You cannot learn this. Performance is so crazy, so crazy nonlinear. That's just not possible that you can get something out of this. And now most people kind of believe that this is possible. For example, for SQLite, right, you can with 2 days of measuring, you can get a pretty good prediction accuracy with regard to the performance property of interest. And we have shown that for a couple of different systems. So we do not focus on a certain application domain. We try to select subject systems, configurable ones from different domains, so including high performance computing, databases, compilers, and so on. Okay, so that's early work, I would say. What is interesting and more recent is this observation that there might be an interesting relation between sampling and learning. And that has to do with the fact that the configuration spaces are heavily constrained and that we have different sampling strategies, which aim at certain kinds of coverage, even looking at the code itself and seeing that every code is included and so on. So that's an experiment we did here. It might be a bit complicated, but let's see whether we can get some insights. So here on the x-axis, we see a couple of plots showing the results for different learning strategies. So CART is classification and regression trees, KNN is K nearest neighbors, KRR is kernel-rich regression, and so on. So it's different predictive modeling strategies. And then in these inner plots, we have combinations with y and x-axis of sampling techniques or heuristics for binary options and numeric options, right? And now the question is based on it's an empirical question in a sense. So which of these combinations perform best in most cases and so on. And here the color code basically means the lighter the better. That means the prediction error is lowest. So lighter, better. Darker, higher prediction error. And you see, and that's actually the main message here, not really, it's not really interesting what these individual numbers are, but there's substantial differences between these combinations, right? And we did also hyperparameter optimization and so on to make this kind of valid. That's the most interesting thing you can get out. What you also see here is that random forest and certain kinds of sampling strategies we did not talk about are really best. And that's really our experience. And you can read that up in this paper. You could even come up with a Pareto front and so on. But I think that's not the message I want to convey here at this point. So that was a pretty interesting time. And now as we talk about time, I would like to come to this dimension, right? So after all, we talk about space-time. So with time, we refer to the evolution of a software system or software project over time in terms of multiple revisions. Here we have a nice example. It's a kind of a simplified database system. You have 100 revisions, and the property of interest is execution time with regard to a certain workload. And what we see in the beginning here at revision 0, we have two configurations. One with compression, and one, so data compression, and one without, which is called the vanilla variant. And what you can see is that the execution time varies, differs. So that's a made up example. So I just want to show what scenarios can happen in the lifetime of such a project, right? So what you see here at revision 25 is that somehow this change affected the compression algorithm. For example, we changed the compression algorithm, which affects the execution time of this variant, but not of the vanilla variant. This can happen. What we also see at this revision is that a new feature has been included. That's the encryption feature, some kind of encryption. And that means that we have doubled, with this, we have doubled the number of configurations. Now we have a configuration with encryption only and one with compression and encryption combined, right? In addition to the other two. So the next interesting thing happens here at the revision 50. So here the execution time of the configuration of compression and encryption has changed. So this hints at a feature interaction because all the other execution time stays the same. So somehow the code that is responsible for the interaction or that leads to that interaction has changed. And that's very interesting to know. And then there are, of course, situations where we kind of patch the basic index structure in the database system, and these changes really affect all configurations, right? And the message is these change points are interesting, of course, for developers, and some of them affect only a part of the configuration space, maybe a small part. So the configuration space might be exponential, and some of them only configurations that are associated with interactions of features, right? Not individual configuration options. So that's what in principle can happen, right? And maybe also other interesting things. So what we wanted to do is to kind of see what's going on in real systems, that in this case open source systems, if we can find those situations. So we started with WP9, so that's a video encoder again. And here we see on the x-axis the revisions. So these are real-world data and the execution time with regard to certain workload. And we see the default configuration in red. And then we have these violin plots showing the performance value distributions over the entire configuration space. And what you can see is that this first thing is that the default configuration is not always best, but okay, but pretty okay, I would say. But you also see is that the execution time varies considerably across the configuration space first, and second, this variance can be introduced by individual performance changes, right? If you go from 1.3 to 1.4, somehow this change affects wide parts of the configuration space. And that's very interesting to know what happened there. So that's why we looked a bit deeper in this. And here we do now a 90% rotation. So we have the revisions on the y-axis and the configurations on the x-axis, and we call these plots solar panel plots, right? And what you see is, so the color code is basically the execution time, and you nicely see that here in these revisions that are of interest, so 1.4 and then 5, really just parts of the configuration space changed with regard to performance. Okay, so it's a bit, yeah, maybe pretty similar information than we had before. But now we can change this plot and say, well, on the y-axis, on the x-axis, we have the influences of individual configuration options and interactions. And we would like to study their individual influences on performance, right? So every dot here is really an individual configuration option or an interaction between two configuration options. And what you see is that, well, it's not just a single option that is involved in these changes apparently. And it's also interactions. So these things happen. Well, but yeah, what do we learn from this? Yeah, it's a case study, right? So what we did is, well, let's look at another set of systems to get a bit more insight what's going on in this domain in a sense, right? And so here is the kind of the summary, right? So all subject systems that we looked at contain configuration-dependent performance changes. That means performance changes that affect only part of the configuration space. Most performance changes affect only a small subspace of the configuration space. That's very interesting, and that was not clear in the beginning. So these are actually hard to find. And we found cases where they stayed long in the repository once they popped up when somebody configured this configuration. So that was, the performance change was introduced very early, but it was not found because it affected only a small part of the configuration space, so small set of configurations. And the reason is that most performance changes we found are caused by multiple configuration options and interactions. So it's that was also a kind of surprise, because we thought that a good number of performance changes were associated only to individual options, right? So, or individual features, but it's many of them are really related to feature interactions in a sense. So that is also showing the complexity of the problem. So, well, this study here was kind of an academic empirical study. So really, we really did brute force measurements to get these data to really see what's going on. Yeah? In a sense, we try to get ground truth data, and we had to make certain assumptions and so on. Question is, in practice, you cannot do that, right? So it's just too much effort. So what you want is to have a modeling technique that is able to get this information with lesser effort. And so we want to detect performance changes in space-time. And here in this plot you see, and it's basically about sampling, right? You cannot really try all combinations of configuration options and time points in time. So you can show this in this nice diagram where you say, well, on the x-axis you have the sampling effort across revisions, could be between 0 and 100%. So 0 means I do not sample anything. And the sampling effort across configurations on the y-axis, right? And what you could do for such a system, you could start in the top left, right, where you say I pick a certain revision and I sample all configurations in the configuration space, right? Or what I could also do is I pick a certain configuration, say the default configuration, and I look over the entire revision history and see how performance changed. I think that's also done a lot in practice. But you want both actually, right? But this, yeah, you want to look at all configurations in all revisions. But this is non-manageable. It makes the problem of performance modeling of configurable systems even worse. So this green area is basically the manageable effort, right? That you can really manage. So what we describe in the paper shown below is a strategy, basically a sampling strategy that is really in space-time, so in this two-dimensional space. And I do not go into the details. I'm just saying a few words about the main ideas. So we do not just do random sampling here, going somehow sometimes in the time dimension, sometimes in the configuration dimension, but we exploit knowledge we have. For the time dimension, we try to narrow down performance changes, right, from left and right. It's a bit like binary search, but more complicated. And in the configuration space, we look for influences of individual features. And basic idea is if we see that a certain feature is involved in many performance changes, then the likelihood that configurations that have that feature, that these are also involved in performance changes increases, right? So then we get a probabilistic model, and that guides the sampling procedure. And well, that's a proposal how to do it, and we tried it here, for example, on the system GNU-XZ, so it's the compression tool. And again, we have the revisions on the x-axis and the execution times of these individual configurations on the y-axis. And we were, of course, interested, can we detect real-world performance changes? Is it not just statistics what we are doing? Yeah? So here we see we were able to detect this performance change, which affects only a subset of the configuration space. And you do not need to read this commit message, but we were really able to understand that this happened and why that happens. Yeah? And the same for this change point. So we did a couple of experiments. So we created a synthetic ground truth data set, because here the problem is that often developers are not aware that these performance changes are in. So you cannot really use the commit messages as ground truths alone. Yeah, so then we also did some controlled experiments, and we looked at some real systems, and basically we found with this technique you are able to identify configuration dependent performance changes accurately and at scale. And we found that interesting because this problem is even worse than the normal performance modeling problem. Well, so that was the second dimension. So now in the third part, I would like to talk about some work that is related to the two, right? But in the sense beyond space and time. So that's basically a quantum form picture. Okay, so one topic that is super interesting and of much interest in this community here is, of course, workloads. Yeah? So you can have different workloads, and reviewers always ask for this. So that's our 10 years experience, right? So what is, if there are different workloads that should kind of affect this picture? And that's true. Here, for example, we see some data for H2. So it's a Java database engine. And if you run it with 3 different benchmarks, which are characterized by different scale factors, so basically blue, orange, and green, you see that they affect the throughput for the individual configurations shown on the x-axis in different ways. It's not a linear relationship or easy deducible relationships. So depending on the workload, we see that different parts of the configuration space respond differently. So it obviously makes a difference. And I know that in the ICPE community, that's kind of a standard problem you have to deal with, right? What is interesting then here at the intersection between kind of performance modeling and configurable system is to see what is happening in these configurable system. Here we see the three plots are the three different workloads. And on the x-axis, we see the influences of the individual configuration options of H2. And that might be interactions, right? And then on the y-axis, we see the throughput. And so the bird's eye view is a kind of looks similar, but some interesting things going on. So what we see here for this option MV store is that the influence of that option on the overall performance varies with the workload and even in the opposite direction, right? That's really a sign of warning. And that's super interesting. Basically, it means that we need to add another dimension between, or in another dimension to the space dimension and the time dimension. You also need the workload dimension, and you want to apply the sampling technique there as well. I also have to say, so there's certainly also reviewers in this chat here that review all the papers. That's true, we know this, but for some things you do, for the other dimensions, you cannot always include all these dimensions because otherwise the experiment setup would explode. But it's obviously a practical important problem that needs to be considered. Okay, so at some point I talked about these performance models and that we are pretty interested in comprehension, right? Not just prediction. And this interest arose in a joint project on high performance computing. So there we worked with people from mathematics, Matthias and Christian, for example, and from simulation science, hardware, HPC, and so on. And they try to solve problems in natural science and mathematics. Basically, they always try to solve partial differential equations. And for that, they run highly configurable codes on these supercomputers like the Icpe, which we used for our experiments. And there's lots of configuration options. For some of them, they call it parameters. For some of them, there's mathematical theory. But when it comes to interactions, there's no mathematical theory kind of predicting what's going on. Only in very few cases. So basically, they needed our help. And what we learned quickly is that, well, they were kind of impressed that these automatic tools can come up with very good predictions, which parameter settings were good for certain circumstances. But in the end, they didn't want a push button approach, right? What they wanted is why. They wanted to understand why is that configuration best? So it does not fit to our theory. Is it an implementation problem or is it something interesting going on? And that's what we learned. So they are interested in these performance models. They want performance models in a representation that they can understand, and then they can look at the model, look at their code, look at the math, and then see what's going on and maybe fix the code or learn something. And what we also learned is that what these predictive modeling techniques spit out is often not very useful, right? So here's a linear model, but it could be a card or something else, right? So and we know that this whole area of explainable machine learning is pretty related, or actually that's an instance of that. So what we started looking recently is more in the direction, not that these models get so large, but in the end, due to the learning procedures, these models are very often showing correlation, right? Correlation between independent variables and dependent variable. But what we want and what these people want is causality. So if I change this, then something else changes, right? So basically, we want some notion, and we introduce that notion of feature causality. It means that given a certain effect, certain performance behaviors, certain energy consumption, or a crash, we want to answer the question, what is the cause? And we want to express the cause at the level of these tuning knobs. We do not want necessarily or not alone some low-level program traces. Now, sometimes you want, but you want this actually first at the level of these configuration options. So, and what we found is in these case studies with these people from HPC is that enumeration or correlation, these characterizations or models that come out of that are not really sufficient. Yeah. So that's why we introduced the notion of feature causality. And so that's not meant to be read here and understood. So what we did is, and that's basically for people who know about this issue of causality. So we adapted the seminal notion of actual causality by Halpern and Pearl. And in parts, for this work, in part, Julia Pearl got a Turing Award. Now it's actually about Bayesian networks, but anyway. So it's really seminal work of the AI community. We took these basic definitions and adapted this to the setting of configuration spaces and features. Well, then at some point we can offline talk about the specifics. What is interesting is that there's an interesting relations to Boolean algebra, prime implicants, two-level logic minimization, and so on. And practically, we have a polynomial time algorithm to compute feature causes, which is interesting because two-level logic minimization is NP hard. But the point is we solve a slightly different problem. Yeah, and we think about feature responsibility, blame, and so on. That's all I think now confusing, but maybe a brief example showing what's going on. So let's say we have a mind pump model or a real mind pump, and we have a specification, right? And this specification here is in LTL. So who does not know about LTL, it doesn't matter. It's a kind of formal specification. Yeah? It asserts a certain kind of stable behavior. And now with a variability aware model checker or a standard model checker, you could come up with an effect set. So it's basically a characterization of the subspace of the configuration space where that specification is violated or the other way around. Yeah. And now talking about causality with that algorithm and that notion of actual causality, we can compute feature causes, we can do some more optimizations, and basically we arrive at a very condensed and we think nice characterization of the effect, right? And that's basically here the cause of the effect, basically the violation of the specification. And we think that's really interesting, but it's ongoing work. So what does that have to do with performance? Well, you could also say for Oracle Berkeley DB, right? You could say the specification, let's say the execution time of this workload or of a set of workloads should be less than 4 seconds. Well, let's see what that is. So standard techniques spit this out. You get a huge effect set. Nobody can understand this. What you could also do is to compute a regression model or a card or a neural network or something. Then you get this, but that's correlational. And there are other statistical problems like multicollinearity and so on. With our approach, you actually arrive at a very decent characterization of the cause of that specification violation. So that characterizes the subspace of the configuration space that is related to that specification violation. So, and at the moment we are working on this a lot, and we have tried it already on a couple of systems, different properties, different specifications, and I think that's a very, very interesting idea, but still ongoing. Finally, I would like to talk about uncertainty, and the reason is that somehow, so far, I kind of assumed that there's a single model for a certain system, right? And when we talked about workloads, I already said that's not really true. What you could do is kind of integrate the workload as a dimension, as part of the configuration space and so on. But in general, it's actually not true, right? So typically you have a performance model for a certain workload, certain hardware, and you get very good results with that. That's what we have shown, right? Really, what you really have is this, right? You have, depending on the hardware, the workload, the learning procedure, something else, libraries you use, or the room temperature. Yeah, you have different models. So actually, this this idea that these influences of configuration options are scalar or integer values is wrong, right? It's just saying, so if I switch compression on, then execution time gets up by 10. Yeah, that's just the wrong idea. So it worked, very good. But if you really would like to use these models in different settings, you need to acknowledge that these scalar values are wrong. So what you really want is basically the probability distribution of the influences of the individual configuration options. So basically here, for example, you do not have a scalar value as the influence of the compression option, which is this little box, but you have a probability distribution showing the possible values and the probability these values can take in certain settings, right? And you can derive these models with probabilistic programming, and you can compute joint probabilities for certain configurations based on Bayesian inference. And I think that's a very interesting thing. And we have a recent paper on that if you're interested in that. We have some empirical results for this. So we tried this for a couple of systems and varied several things. And what we found is that the point estimates that we get from this Bayesian approach, you can use it and then shrink it down again to point estimates, match the accuracy of state-of-the-art predictors. So we are not worse with that when it comes to point estimates. When we do interval estimates, right? So when we're talking about confidence intervals, so are we close to the actual value and so on, then we can substantially reduce the prediction error. And what we also looked is whether the confidence intervals that we can compute from these probability distributions reliably capture the performance uncertainties that we have in these systems, and we measured that. Well, that's it, basically. That's all I got. Try in the interest of time not to give these boring summaries, and open for questions now.
Thank you, Sven. Thank you. Very, very interesting talk, as I knew. So there is time for questions. I've seen first Samuel Kunef has posted something on Slack. Samuel, if you like, you can formulate your question here.
Yeah, so it was more like comments on activities in this direction. So first of all, thank you very much, Sven, for excellent and very interesting, inspiring keynote. There are many, many activities in the performance community in similar directions. I mentioned one of them on Slack, which is a Spec DevOps performance group. Andre van Hoorn from Stuttgart and Corpo, who is here. I mean, both of them are here. They're leading that activity on performance regression testing. But let me come to more like a question here I wanted to ask you. I think it's also a matter of two technical issues. If you want to tackle all these configuration changes, as you mentioned, explosion of the state space and so forth, there is also the problem of automating the tests. So test automation is one important aspect. And another important aspect is result reproducibility. So it might be that there is fluctuation in whatever you're observing, as you mentioned, uncertainty. So reproducibility in this context is also very important. And one third aspect, again, even further introducing complexity, is the problem that even if you don't change anything as the system works and continues to operate, some aging, software aging might happen, as people here like Alberto could speak a lot about this topic, software aging, right? Sometimes performance just degrades for whatever reasons as you proceed with time. So my question, have you also, or are you looking into also such aspects, automation of the testing, reproducibility, and aging?
Right, yeah. So as we are academics, right, so we our goal was have a certain generality on the one hand, so we do not want to look at a specific domain and dig deeper. On the other hand, we limited scope, certainly, right? So these problems are all known to us, but what we did is, in order to do our experiments and all our research, in a sense, we kind of fixed them to a set of systems where you do not have these problems. So we have seen that this the set of systems we looked at where a set of systems where you typically do not have these problems. We do not look at cloud systems and so on, where and flaky tests and these things, right? And these are, that's all very right. So we at the moment we have another project with Andreas Seller on flaky tests and so on. But it's really orthogonal, right? And that's very important to acknowledge. The interesting thing is, if there are solutions for flaky tests and test automation and software aging, and there are, it is interesting to see if you add this dimension, if something interesting happens. Yeah, when these dimensions are orthogonal, even better. Where you say the software aging is a problem, but the configuration space is not really affecting this problem. It's still there, but there's nothing interesting going on. Yeah. For example, as we added the time dimension, we could have found that, well, most changes really affect all configurations, yeah, or interactions. And then you would say, well, time is a problem, configuration space is a problem, but in the interaction between these two dimensions, actually no new complexity is. And I think that's what we should explore, right? So first, increasing internal validity, look at these dimensions individually, and then combine and see if interesting phenomena are occurring. So it's really, in a sense, basic research we are doing. So often people say software engineering is it's very applied and engineering discipline, and that's okay, that's true. Yeah. But here we have really empirical questions. So I see this set of systems we have out there as a population, and then you are biologists studying them and see, well, for how many systems interesting things happen with regard to aging and configuration and so on. Yeah, that's the answer. That's maybe unsatisfactory, but yeah, so many interesting things to do there. Yeah.
Thank you.
Thank you very much.
I propose to spend a few more minutes because there are several questions, and I think the talk was interesting. So I will not cut anybody to have the occasion to pose questions to you, Sven, if you are patient enough. So I go in the order of chat. There is Vahid Azari. If you are here, you would like to formulate the question by yourself without me reading it. Vahid.
Yes. Hi. Thank you for the nice, very nice, interesting talk. It's a very simple question. So you talked about effect sets. I'm just wondering to know, given a history of releases in repository, and let's say we have all these automated performance test outcomes stored somewhere, how would we go about computing the effect set from that?
Yeah. So this was so this work on uncertainty. We did not apply it at the moment for the time dimension, right? But one has to be careful here. It is not a white box root cause analysis. When we talk here about feature causality, we would like to know which variables in this black box manner are really responsible for the different observations. It's not about the questions developers have, where in the code, why was it happening in the code, and so on, at which point. So that's not what we do at the moment. I have an interesting disclaimer here. You see that we have some work on white box analysis where you say, well, all this black box modeling is nice and good, but you have the code also, right? And you would like to know at which point this line of code was introduced and why and so on. And yeah, this did not fit into the talk. There's also, we work with Pujan, for example. I see him in a video chat here on this and so on, and a couple of other people. Yeah, so these feature causes are really here is this, basically it means a feature cause is, so if I switch the decision on that feature, is that really making a difference for performance in really in a sense of causality? So it is based on counterfactual reasoning. If I did not do the switch, then it would not happen. Yeah. At the moment, we just applied it to configurable systems, not without time. But of course, with white box analysis, then it comes really into reach to just not say developers in this revision this problem was introduced, and in this regarding these configuration options, but also which lines of code and so on. But white box analysis, we have with Puyan, for example, we had a nice time running data flow analysis on code, right? So that's a whole different game. Yeah.
Okay, thank you. There is one question from Connie Smith. Please, Connie. Are you still there, Connie?
Yes, I'm here. So
Okay.
thank you. That was a very interesting talk. The question I had is, are you considering, well, it appears that you are considering all of the parameters individually and equally, and I'm wondering if you thought about maybe combining parameters that affected memory management, scheduling, other things like that into groups, and perhaps reduce the problem space that way.
Yeah, well, at the moment, so I'm not sure if I got the question, but I'll tell you what we do at the moment. So in our community, there's work on multi-objective optimization. So it's a specific problem that, well, if you have performance and energy consumption and memory and something else, the compression rate, if you want to view it as a dependent variable. So what is the sweet spot there, and how can I find the Pareto front and so on? So we did some work in this direction, but at the moment not, our group. But there's many things going on in our areas, and when it goes to this, what we are doing at the moment is, and I think also Puyan's group is working on this, we try to view this problem through the lens of causality. Yeah, so we would like to know, well, here's a configuration switch and there's the execution time. So now we want to have a causal chain, which could be in part recovered through white box analysis, but it goes through the entire operating system, software stack, through the hardware and so on, right? And you would really see, for example, we know that very often energy consumption and performance is correlated, not always, and that's also an interesting question in your community. But I would like, for example, to know whether a feature affects the energy consumption via performance, via the cache, or how, right? And then you arrive at these causal chains, and I think our step regarding feature causality and also the work regarding white box analysis help with that. Puyan is looking, for example, in causal inference. It's a set of different techniques that could be useful here. Yeah.
Thank you.
Thank you. One last question from Murray Woodside. Murray, can you speak?
Oh, thank you, Vittorio. So my question is a little bit like Connie's, but different. You have not just the source code, but the architectural understanding of the system, which might suggest certain relationships between feature changes and between, anyway, that these might assist, not so much the causality analysis as the sampling of searching for interactions to help find things. Have you thought about that?
Yes, basically, we are not doing research in that, but it's pretty clear, right? So here we have a kind of approach that is as general as possible. But if you have domain knowledge, of course, you should use it. And we use it all the time, for example, for database system, if we do symbolic regression. I mean, we know that certain index structures have a certain functional influence on something, and that we can use in sampling, in learning, and so on. We can prioritize certain kinds of interactions based on the knowledge we have on the features, right? We could also look, use white box information for that and seeing these are basically functionally independent and so on. We did not really do research in this direction. For us, it was always, we acknowledged this information source and we used it when necessary. I think this becomes interesting if you take this set of techniques or similar techniques and go to a specific domain. So for example, here in Saarbrücken, we have this Max Planck Institute for Software Systems. There are some people in cluster computing, right? So they have a certain kind of systems. And there it's getting interesting to use these general techniques and instantiate them and augment them with the specifics. In a sense, in this scenario of high performance computing, we used it already. So we were aware that they do not have a single CPU with 8 cores, but they have 400,000 cores on Uqueen. And they are not on the same chip, and there are certain relationships and so on. And that can be included. At the moment, we do not have kind of a research project. So kind of, that would be interesting, a methodology that helps a certain domain engineer to apply this. Yeah, because at the moment the domain engineer has a general techniques. That's what we do, academics, and right, and then they need to make it fit to theirs. But is there a methodology, and is what can I exploit from what I know, and so on? I find that very interesting. But so far we did that for our purpose, but it's not really so in our group a research thing at the moment.
Okay. Unfortunately, I think we have to stop here the discussion because in order to leave 10 minutes for the break. So we should, Sven, you can go on the chat, and also I suggest you to go to the channels on Slack because there are many congratulations for your talk and also a few other comments or questions that you can discuss offline. So I want all of us to thank Sven, even because today is Sven's birthday. I want to tell you, and so let's say happy birthday to Sven. I didn't want to reveal this surprise, so he was with us on the day of his birthday. So thank you very much for this excellent talk and the following discussion. Yeah.
Thanks a lot. So one comment on this. I will go to Slack chat, but I mean, it's 5 p.m. here and the family is waiting. So I really try to be there around tomorrow and so on.
Yeah, yeah.
But today I have to, I mean, otherwise they will be very
offline discussion can be conducted anytime.
Yeah,
It's
yeah, okay. Yeah, so I try to attend also the social thing tomorrow and so on. Let's see.
Please go and celebrate your birthday, of course.
Okay. Okay. Thank you.
Thank you
Thanks
very
a lot.
much. So coffee break, everyone with his own coffee, and we will resume at 5:30 with session 1. Thank you very much, everybody.
Thank you.
Bye.
The same Slack, right?
Yes.
I mean, the same Zoom channel for session 1, right?
I guess everything is the same. So I think it's a one-track conference.
Yeah. Cool.
But there is a Slack channel dedicated to the session.
Yes, I know. And we've been interacting there. So people have put slides and questions and discussion already. So everything's good. That was a very good keynote. Victor, do we start on time?
I don't know. There are 68 people now, so it's up to you.
It's interesting because the registrations is 4 times larger, but the attendance is similar to face-to-face.
I think that's a normal. I think that's very expected, actually.
Okay. Yeah, it comes straight from traffic engineering models. The number of concurrent users versus number of registered users, right?
I think we need to start on time because we cannot back up to the schedule.
Right. So I had all the presenters here for session 1. Let's see. Let me get my finger. Shuhan, are you here? Can you unmute? People, so he's on Slack. So it's the speaker, and then we rotate. And welcome everyone to session 1 of Icpe. It's a very exciting list of topics here. And the first plan talk is supposed to be Shuhan, Conf Prof, white box performance profile of configuration post options. Is Shuhan there? No. So the approach we're going to have is I'm going to give like a 10-second introduction. Then you're going to have a 3-minute teaser followed by 7 minutes of questions and answers, right? So since I don't see the first presenter there, I suggest you move to the second presenter. Nitin, are you there?
Yes, I'm here.
Okay, so let's start with you, Nitin.
Sure.
And, please share your screen. Nitin is a PhD student at the Indian Institute of Technology, Bombay. His research interests are performance improvement in blockchain protocols, specifically improving the throughput and the amount of computation supported by blockchain without altering existing security assumptions. Okay, so go ahead, you have 3 minutes.
Yeah, so here, my name is Nitin Avtare. This is the joint work with Saurabh Das from University of Illinois and Professor Vinay and Professor Umesh from Indian Institute of Technology, Bombay. So here in this work, we are trying to reduce the block validation time by using the result of block creation phase. So this this motivate us to solve the problem. So what we observe is there is a considerable amount of overlap between the block received from the other nodes in the network and the potential block that node is going to find. So the question is, can we cache the result of the block creation phase and reuse that reuse those results to validate the block? The answer for this is yes, but the reusing is non-trivial because ordering of transaction matters. So for example, in this slide, if I execute transaction tx1 followed by tx2 and tx2 followed by tx1, I mean vice versa. So the final result that we are going to get is varying. That how we can see in the slide. So the ordering, because the ordering of transaction matters, so we have to ensure the dependent transaction in the received block as well as the created block should be the same. So to check the amount of the transaction that we can skip while validating the received block, we have set up the we set up the 10 different nodes in 10 different geographical regions. And what we observe is we can skip the 80% computation can be skipped for more than 75% of the blocks. So we have also validated our measurement by estimating the similarity of our 10 nodes from our 11 nodes, and we have actually calculated the similarity of 10 of the blocks in the 10 nodes. And what we observe is there is a significant difference between the estimated similarity and measured similarity. So what we observe is the measured similarity is more than the estimated similarity. So then we come to the Renoir, so following this measurement and the motivation, we come up with the approach that we will store the result of block creation in the while the creation phase in the tabular format, and while validating the block, we ensure that the transaction in the which appears in both the blocks, that is the received block and the potential block, I mean created block, they should read the same version of all the variables that is accessed by the transaction. So Renoir ensure the ordering of the transaction by ensuring the same version. And we evaluated our approach on the two measurement setup. So first one is we connect the Renoir node with in real in the production Ethereum network, and we observe that the 50% reduction in the block validation time. Also, we set up our small 50 nodes setup, 50 node network, which is kind of mimicking the properties of the production Ethereum network. And we observe that like even after including more amount of computation in the block, Renoir will take tiny fraction of the second, while the Navy Ethereum approach will take over a few seconds, here in like 5 seconds and so on. So here I am, this is the summary of what our observation and what we gain. So the last point in the summary is it's not explained in these slides. So it is available in the detailed talk that is uploaded on the Icpe 2021 YouTube channel. And so I am open for your question answer now.
Thank you very much. So we have questions. Before I ask the question that I put on Slack, and we have already had some discussion. Anybody wants to ask a question now on the floor? Have any questions? There are no questions. I'm going to ask my question, which is, so the approach illustrates the common performance versus security trade-off, right? There is always a trade-off in implementing with, and as you cache the state from transaction execution during block creation phase are used to enable node to skip the execution of these transactions during block validation. Is there a potential for security vulnerability with caching or validation? Can this validation be reused by some kind of intruder, some kind of man-in-the-middle attack, capture playback attack? I see potential for security vulnerabilities. What's your answer for that?
First of all, I am not sure so in the blockchain, like particularly permissionless blockchain, the playback attack is not, I mean, is not possible. I mean, I should not say not possible. It's very difficult to make a playback attack there, because the block creation is going to take, it's basically block creation is solving, they are solving the mathematical puzzle, and solving that mathematical puzzle is going to take considerable amount of time. And because of that, it's difficult to make a playback attack. And every node, so like I am not sure if I understood the question correctly, but here the intruder won't come into the picture because the whole network is open network and it is available for everyone to join, and everyone is kind of solving that puzzle, and whoever will come up with the solution first, he will broadcast that, and other are just validating the block by using the result they locally have on their own created block. Yeah, and this they are not sending this result, like locally cached result, to anyone. So I'm not sure like what you mean by the intruder comes into the picture while using that.
I understood that you're skipping some of the validation of the. It could be a misunderstanding on my part, but my understanding of our approach was keeping some of the validation to provide the speed up.
Yes, sir.
So if I can, Albert, I have a similar question. I could try to ask in a different way. So Nitin, if there would be a corruption of the cached values, I understand they are cached locally, but let's say that somehow someone interferes with them. What would be the consequence? What would be the consequence of that?
Yes. So if there is some corruption in the cache data, then Renor ensure that node will re-execute the transaction. I mean, so while validating the received block, Renor ensure that it will execute the transaction and validate again. So it won't use the cache data for those such kind of transactions. I mean, if the data is correct.
So you mean that there is some kind of system or way to check the validation of the cached value locally?
Yes. So yes. So we are like if there is a version mismatch, then it will re-execute the transaction again, like for validation. If the data is corrupted, then it will ultimately going to result in the version mismatch, and node will re-execute the transaction. That is how.
That's what I thought, that a corrupted cached value would end up for the validation failing, right?
Yeah.
And then you wouldn't be able to publish that validation because it would be not correct.
Yes. So like, if the validated, I mean, the stored cache data is invalid one, like it's corrupted by any mean, or someone corrupt that data as a part of attack, then while validating the received block, the node won't use the cache data. It will go with the normal procedure of validation.
Okay, thank you very much for a great work. So let's move to the next one.
Thank you. So if there are any further questions, you can always post in Slack. I will try to answer them offline.
Very good.
Thank you.
So the next presentation by Henning Schultz. It's a context-tailored workload model generation for continuous representative load testing. Henning is a consultant for the application performance management at Novatech Consulting in Germany, supporting customers regarding performance monitoring, load, and performance testing. This work is part of his PhD thesis, which was presented last year at the University of Stuttgart in Germany. You can share and start your talk, Henning.
Thanks, Alberto. I'm just trying to share my screen now. And I hope you can see it. Great. So what I'm going to talk about today and what's the content of our paper basically is the question how the workload of a load test can be modeled. And basically there is a statement from Ferrari from the early 70s already. And he said that the main objective in selecting such a workload should always be representativeness. That is, you should try to model the workload that way that it represents the production workload. And in my opinion, that totally makes sense. But if we look at modern application systems, things get a bit complicated. For instance, here there is the number of concurrent user sessions being active over half a year in the student information system, so some kind of campus management system of Charles University in Prague. And what we can see is, well, workload is not really stable and there are lots of different workloads over time. But the good news is we can also observe that different kinds of workloads correlate with something which we call context in our paper. And with context means something like, for instance, there was exams and during exams there was a specific workload. During vacation there was a lower workload, meaning less number of concurrent sessions. Course enrollment has some sharp spikes, etc. And when it is about load testing, we now can say, okay, we don't want to test with the whole workload we are observing in production, but more like the workload in a specific context, like only a small subset. And so when it's about load testing, it's also interesting to look at the future for sure, because load testing often has to go to prepare for future workloads. And future can even be different than what we observed in the past. For instance, thinking back when COVID-19 pandemic started, all the universities had to do online tuition, also Charles University, with most likely a very different workload, most likely higher workload at the system. So we would also like to be able to forecast future workloads. And that's why we came up with an integrated and end-to-end framework that always starts with a stream of collected user sessions. We then apply an incremental clustering algorithm to that sessions and learn kind of a knowledge about the workload going on in production and store them in the repository. And we also store context information. So like the fact that there was tuition or course enrollment or something like that. And then we have a knowledge base, which we can use to actually predict the workload for load test that simulates future user behavior. And for that, we have a context tailoring description language where you can specify what you would like to test. And the context tailoring step then selects data from the repository, applies some time series forecasting, and aggregates everything into a concise workload model. That was our paper in a nutshell. For more details, please have a look at the video and the paper, and I'm happy to answer any question.
Okay, thanks for your presentation. Anybody on the floor wants to ask a question to Henning?
Yes, I have a question.
Sure.
Hi. It's quite simple. I mean, you talked about clustering in your video presentation. Can you elaborate a bit more on that in terms of what kind of clustering you used? Is it because, as it seems in the visualization, you could even get away with some kind of sharply looking at it visual type of clustering deal. So can you talk a bit about that?
So what we are clustering is like user behavior on an individual basis. So what we are getting is this stream. So all these session logs, basically a log file with one entry is one user session, and one user session consists of multiple requests with some timing behavior in between. So user sends a request, then waits for some time, sends another request. That's the input data. And then we treat each of these sessions as one data point and cluster them such that we get basic groups of users that behave similarly. And these clusters we later take, so we handle them differently, like we forecast each of them individually to be able to predict the mix of different users with their individual behavior. And the algorithm actually bases upon k-means, where the sessions are encoded as basically a matrix. Each session is one matrix, and then we apply k-means with some, the incremental part basically is based on the minimum distance. So new sessions are assigned to that cluster where they are the closest to the centroid. That's the algorithm in a nutshell. Does this answer your question?
Yes, it does indeed. Thank you very much.
Yes,
You're
so
welcome.
I have a related question, which is, so predicting the future is dangerous, right? So you have to make assumptions. So what are the main assumptions in the model used for forecasting? And what is your expected accuracy? Have you validated this with some sample data?
Well, for sure, we have in our evaluation, we have predicted. So we have applied the forecasting and we have checked how close it was to reality. So first of all, what we are using are forecasting tools that have already been evaluated quite detailed. One tool is Telescope from the University of Würzburg, and one is Profit from Facebook. And these tools are quite nice because you input your data and they are tuned to be able to handle lots of differently looking time series. And so, for instance, Telescope then somehow automatically selects which method to apply, and we basically just use that tool. And so our assumption on the one hand is that we have some kind of time series that somehow fit to these models of these tools, but in our evaluation that worked quite well. Even though we also found some limitations. For instance, these tools were not necessarily made to predict the correct curve shape in some cases at least. So for instance, they produce very sharp jumps. For instance, when we have a look, so when you consider these contexts and when you have a context switch, like first there's tuition or maybe there's no tuition and then tuition starts, where you have a jump in the context, like from tuition is not present to tuition is present. Then we also had a jump in the forecast because the tool was more made like this change actually was not correctly predicted. So this was kind of a limitation we found out, but in general, it worked quite well and the predictions were quite accurate.
Okay, very nice.
So, but still we are relying on these tools which have been evaluated in much detail.
Yeah, it would be interesting to have an explicit list of what are the main assumptions, right? Is that there is some kind of cycle, that there is not a big, right? So one of the ways to use these forecasting tools is when it doesn't match, you detect a problem. We used that at Bell Labs back 20 years ago. So you know that the traffic is periodic, but then there is a big gap. It's because there was some resource failure, right? Something like that. Huh?
Yeah.
Very nice. Thank you. Congratulations on your PhD.
Thank you.
And okay, you can move to the next one. And so next speaker is David Daly, creating a virtuous cycle in performance testing on MongoDB. So David, the staff engineer at MongoDB, focus on server performance. He has helped build and design MongoDB's performance testing infrastructure from the ground up. David has a PhD in electrical engineering from the University of Illinois, where he worked on performance and dependability modeling. So you can share your screen, David. Start your talk.
The hardest part is remembering to unmute myself. Thank you. So I'll try to stick to the 3-minute side of the 3 to 5 minutes here. So at MongoDB, we're trying to understand the performance of our software and when it changes. And the paper is all around this. So we have engineers constantly developing the next feature, the next bug fix, the next performance optimization, and committing those changes to our software repository. And we want to know when the performance changes because of that. If it regresses, we want to detect it and fix it quickly. The faster we detect it, the easier it is to fix. And the sooner it's fixed, the easier it is to detect the next thing. If we can't fix it, we want to understand it so that we can mitigate it and let our users know how to mitigate it when they're using it. And sometimes things get faster, and we want to know that also so we can lock in that improvement. And so we can, again, let our users know so they can take advantage of it. So this paper was about 4 changes we made to improve that process of detecting and understanding the performance. And the key to the story is trust. Software development is a social process. Building a system isn't enough. You also need to build trust in that system. And when you build trust in the system becomes better. It gets used more and you invest in it to make it better. So the 4 changes were around, first, processing results better, which was largely a social process that was discussed in the paper. Have a negative result here. We did work to try to control our noise better by using outlier detection on our canary workloads to detect when we shouldn't trust a result. In theory, it was very promising. In practice, it didn't make our process better. So we ended up turning that off. A lot of promising stuff there that we might come back to, but for now it was a negative result. Adding more results types, so we have a much richer description of our system and its evolution, while not overwhelming the results and the people looking at the results. And finally, improving our ability to compare arbitrary runs. The system as described nominally is finding the changes in time, but sometimes we need a more holistic view. So when we get to release time, we need to look back and know net what changed in the last year. Not just every single performance change, but where do we stand relative to the last release? And so we put in infrastructure to support that. Going forward, the things I'm really interested in and that build on this work are a multi-way optimization problem to make our performance testing system better. So putting in the ability to simultaneously maximize our signal to noise ratio, get a better signal out of the system, maximize our test coverage so we know more about our system, while simultaneously minimizing the detection time. Faster we find things, faster we can fix them, and simultaneously minimizing test cost. Many of the things in the past that we've done have traded these things off. We would like to simultaneously optimize all of these. And this ties in very heavily to Sven's keynote. I'm really interested in that kind of stuff, and it relates here. A few quick plugs. I'm in industry. I would love for you all to solve my problems. So if you think my problems are interesting, let's talk about them. I'm in industry. We hire people. Send me your resume. Send me your students' resumes. And trying to make it easier for everyone to work with us and solve our problems, we publish stuff like this paper. And so my website has links to what we've tried to describe our system and what we are doing and our problems.
Thank you,
so
Dave.
Thank you.
Yeah, very nice talk. So questions from the floor? Let's see.
I have one. Oh, sorry.
Sure.
Can I go ahead? Sorry, Wahid. Thanks for the talk, David. I pretty much liked the end of your talk as well when you mentioned about the data sets, as we've been talking about this for a while. Could you elaborate a bit more on why like the noise outlier detection, in your opinion, was like seen as not successful? What was the problems that you found there? Yes, thank you.
Absolutely. So for background, we have some number of tests that run that measure the performance of the test system, not the software. And so we expect these not to ever change. They should just be flat. And well, they do change sometimes, but we expect them to be flat. And sometimes we get outliers on those. And so if we get an outlier on that, we know to suspect the results of the production test runs. What would happen though, so we got good at detecting those and we leveraged previous work to find out when that happened. And so we built an automated system to rerun those tests when that happened. And there was a confluence of a few things that happened. One, it was a little sensitive, so it reran a lot of tests, which is expensive, right? Remember my thing, we're trying to optimize spend also. We have a finite budget. But two, a lot of times retrying it got the same result. So either something happened in the environment that was a static change, AWS changed something, and so rerunning it 3 times just got the same results 3 times. Or it might be a transient thing that happened for a day, but our algorithm retried it 3 times on the same day. And so it was a useless change. And so just the cost, both in computation time and in availability of the results, right? It slowed things down because things were being rerun, was just too high. And there were other things we were working on that gave us better value. So it got turned off. I think some of that technology is going to come back and be used in other places. But for now, that just got turned off.
I see. Thank you very much.
I'm fascinated by the question too, because it's the first time I've included a negative result in a paper. So that the first question goes to the negative result is probably good feedback on that.
Yeah, well, it's a good lessons learned, right? And if I just may, you had on one of the later slides that the noise was actually still small compared to the big, like sort of the alert cases that you have, about less than 10%, if I recall correctly. But you're still telling me that the cost of it was still seen as a, let's say, a negative impact of all of this, right?
Yeah.
Mm-hmm. Thank you.
Any other questions from the floor, or should we go to Slack?
Actually, I'd like to ask my question. So it's, I had 2 questions. One was basically, it follows the previous question about the canary. So basically you're saying you probably didn't send in the right canary, and regardless of the fact that you abandoned the false positive detection, would those like whenever those baseline tests would fail, would they always include all the false positives? So basically, I'm trying to say that were there any false positives that would not trigger these canaries?
Oh, absolutely. Absolutely. Our canaries are pretty simple at this point because they're easy to reason about. And we only have a limited amount. We were running them on every set of tests, so they had to be fast. Okay. So we had a very tight CPU loop. We had a network bound test. We had some IO bound tests, and we just run them quickly. We run them on a subset of the systems. It's limited coverage, so it's very easy for something to happen that wouldn't be caught by those canaries, but they still would catch a surprising amount of stuff. When we first put them on, very soon after we turned them on, was the Spectre meltdown stuff. And the canaries very specifically caught the Spectre meltdown patches that AWS mounted, and we were able to track that down. It was very, very specific signal, something that you did a lot of CPU and network, so it was going in and out of kernel space, showed a very clear signal as all our tests changed, and we're able to see, hey, this is we don't need to go track somebody down. We just need to figure out how to deal with the fact that all of our test results changed.
So the time for this discussion expired. So we're going to have another 10 minutes in the end to summarize and to have everybody discussing what was not discussed in from the Slack. But let's move to the next one. Give a fair 10 minutes to the next speaker. So thank you, Dave. It was a great talk. And next speaker is Mark Lesnick. He's a researcher and PhD candidate at Ulm University in Germany. His research topics focus around time series data analysis and synthesis. So you can share and start your 3-minute pitch.
Yes, I hope you can all see my screen and also hear me. I'll try to keep it in time. So yeah, I'd like to talk a bit about, as it says, a multivariate time series synthesis using the GAN networks that we've used. And of course, it was a team effort. So for my colleagues here in Ulm and our colleagues in Great Britain at BT, and of course, guys at Sweden who helped us with the evaluation to perform. Basically, what I'm showing here in a short animation is how the networks, starting from noise, were able to distinguish the specific distribution of the data that we're trying to mimic. So first of all, let's talk a bit about why the motivation to do synthetic data. And instead of, I think, reading this all to you, let me just give you a brief anecdote on the fact that we here in Germany just submitted a national proposal for a synthetic data project. And I think all of you in research can relate to that. And it seems that in the not so big country of Germany, 100 other research groups had the same idea to do that. So basically, I think that that's all I need to tell you in terms of this is a very hot topic right now. Why would you want to synthesize data? Well, you would like to do that to increase the general availability of your data and the accessibility of your data. You would like to do that because sometimes you have very sensitive data that you still would like to share with someone and circumvent things like we're in Europe here, we're subject to the GDPR. You would like to perform some kind of diff analysis and say, okay, well, I have the data for maybe only several servers and would like to see how it looks with more servers or enhance classes, for example. So our main contributions lie in basically the ability to generate a very large amount of multivariate time series data, which in its distribution very closely mimics the real data and basically generalizes it. We've open sourced a lot of CDN data, so content delivery network data from the BT network over around 3 months, which you all can use. And we were looked at time series characteristics in terms of synthesis and not only. So basically, how can we characterize data sets in terms of maybe time series synthesis and time series predictions? And what you see here is basically in red. I've tried to overlay it. Of course, it's not, I tried to overlay it in the sense that the red line shows how the original data looks like, and the others show how the generalization occurs. So basically what you can see is that with some noise around to it, we're able to mimic and generalize the data in the sense that you get a statistical and basically a statistically similar data to what you already had, without, of course, the data being subject to GDPR and so on and so forth. You're now able to share your data or maybe even enhance your data. Right, so maybe if you talk about the scenario that Henning described, you would maybe could multiply the data that you have or use data from other university, which beforehand you were not able to use because it's still user data. And what we would like to look at in the future is basically more statistical properties, more practical applications. And you should still consider that, of course, if you look at the system under test, right? So what we're looking here is the workload data that results from the inputs to the system, right? But we would also like to look at the data that we input in the system. So we have the input workload and the output workload. Here we're only looking at the output workload. So we cannot consider parameters going into the input workload. This is, I think, basically a bit answers David's question that he had on Slack. And in the future also, so as I said, class-specific data generations, and maybe not only time series, maybe something like database queries, and of course use more synthetic data to open source even more synthetic data, because once the data is synthetic, it's not subject to so much regulations, and of course provide a more comprehensive tool sets for characterizing the time series. So I'm looking forward to your questions, and thank you for having me.
So questions on the floor?
Yeah, I have a question. So thank you for your talk. So we do a bit of data generation with GANs as well ourselves, but one problem we have is how do you evaluate the quality of the generated data? So do you have any thoughts on that?
Yes, so there's a lot of problems with that because essentially, let's say it very simple, the GANs or neural networks in that sense are quite stupid. So before if we try to input those parameters into the network, something like a mode collapse happens. So so you cannot tell the network what you're looking for, unfortunately, because then it just learns the simple distribution and goes directly to this answer. So basically what we did is we run it in some sort of a CI/CD pipeline, and we do the entropy and all those statistical evaluations on that and see if it matches. But basically, so there's a lot of stuff there specifically for GANs. There's the Frechet score and things like that in image generation, but there's unfortunately not a lot of things for that in the time series domain. So this is also what we're working on, just looking at what other people did back in the day. So there's heaps of research on characterizing time series data, right? So we're trying to use all that available information. So as I said, approximate entropy, so basically the predictability of the data, and things like the co-integration tests in terms of is the data moving in the same direction and things like that to allow us to perform this evaluation. But we haven't yet bridged the gap in terms of the back propagation to the data. So saying this is not looking like we wanted and change some things like that. I hope this answers your questions.
Yeah, for sure. Thank you.
Okay, so let's see. I have so Dave asked a question on Slack about the degrees of freedom. You want to discuss this or?
Yeah, sure. So basically, this is, and I think I can also directly plug in the BASI, the vision paper that we will be presenting in the next session. So the thing here is, as I already said, so if you consider the system under test, you have some kind of an input workload which results in the output workload, and we are currently looking only at the output workload. And of course, we would really like to look at the input workload, right? But it's far more difficult to get that data. But in this sense, what we're only looking at is the output data resulting from the input workload. But what we do not bridge is in terms of is this peak, related to some kind of operation that you performed on the database in terms of configuration, or maybe it was just a noisy neighbor doing a lot of whatever, on the other virtual machine that caused the higher CPU usage, for example, right? So we cannot distinguish between that at the moment. Once we have more of the input data also, then maybe we can bridge those causalities and definitely look at that.
Thank you. Any more questions?
Yeah, I have one more that I just tossed in. So the challenge with all these things is getting data to train on, right? And so you actually have real data. Not only do you have real data, but you're able to open source some of that real data. What were the challenges there? How did you get them to actually agree to publish their data?
Well, that's a good question, because I was previously at Mercedes, and basically we were also having all the same trouble. I would say that it's in terms of company-wise, it's just getting through to the management, because this is research, and you just have to get them to accept that the value proposition is high, and that the company can somehow benefit from it. And for BT, of course, it was, okay, if you do that, then we will be able to research in terms of, how to place the caches strategically, and you can save, because those things cost a lot of money. Then you could save, one such a server or one such a switch costs like whatever, 200,000. And then the management directly look at it in terms of numbers, of course, and this is much easier. And this is, of course, what I think, once you have something that you can say, now you don't have to open source the data, you can just run it through this sensitive thing, so the synthesis, and you can open source the data, right? Because for us, we don't care about the single user, right? We just care about the distribution statistics. This is what we would like to analyze, right? So once you have the synthetic data, you can then easily ideally easily share it. This is the topic of security, which of course we would love to look at more. Are we actually able, to hide the user in there, and is he still, is the possibility to not find the user in the synthetic data is there?
Okay. So we have several questions still. I suggest now we move to the previous papers with questions.
Thank you.
We didn't get. Thank you very much, Mark. And for Henning, there is a question. Is there some way to compare the predicted workload across time and see whether user behavior changes or just portion of different user changes? Is it from Jack?
Yes, at least we try to do so. So what we actually did is we had all these number of concrete sessions per user cluster, let's say, so per user group. And what we did is we said, okay, let's cut the data at some point, and we have, let's say, some future and some past data. And we had a perfect forecaster. And we basically gave this perfect forecaster the information about how these time series evolve in the future. So they can perfectly predict the time series, but have to use the user behavior from the past. So from that period we said it is the past. And we actually found out that there was some inaccuracy. So just knowing the future values of this time series was not fully enough. And in some cases that totally made sense because we found some very short periods, for instance, during course enrollment, where we could see that, well, the students clicked very more frequently than usual because they wanted to enroll in their favorite course. That totally makes sense. In some other cases, it might also be, the reason might also be that the data we learned from was a bit too short. But we just talked about a similar problem. It's hard to get more data. We really need the individual user sessions, and we got them from half a year, which is great. But getting even more is even harder, for sure.
Okay, so let's go to the questions from Slack first that were not asked. This is for David. So to minimize the cost of performance testing, have you considered approaches to review problems early, like reducing test time and having additional tests, use increasing load levels so you reveal the problems early?
Yeah, we're really interested in all sorts of stuff like this. And we want to do more risk assessment, more analyzers. We do add things like that, and they're not so hard to actually plug into our environment to start looking at things. I mean, I would love to have, so we had sort of that vision there of I want to optimize all these things at the same time. Feeding in, I would love to have a risk assessment based on correlations and static analysis of the changes to figure out which are the changes most likely to introduce a regression and test those more and make sure I test the right things with that, and maybe warn people before they commit their code that you need to test because they're at a high risk of introducing a regression.
As my assumption from the plots we show, it looked like you have constant load tests, so like it's all straight lines. Huh? You don't have, because sometimes there's something that is unstable point that's about to break. So if you increase the load a little bit, you start seeing lots of stuff.
Yeah, and that's a really good point. Our tests, I mean, we have a lot of tests now. In the paper, I think I called out that we had about 3,000 tests and 6,000 results that we could get per commit. We were starting at a point where everything were the simple tests. You run something in a loop and you measure what the throughput is. And that was sort of the point of adding in the more metrics, is being able to express more dynamicism in the model. So we've been adding in more rate limited tests, more tests that vary over time. We've actually just added a feature into our generator to be able to dynamically sweep the space and figure out what is or get an estimate of what's the maximum throughput, right? So we can do a test that runs at a rate relative to that. And we're trying to work those in. One of the great things and one of the awful things about being a fast growing company is we have lots of really good and hard problems and limited resources. So we have to pick and choose where we are, and things that can get into the incremental changes are easier to put in. And so we do put that incremental change of being able to sweep this space and build on it. And that's something that we can continue to build on and do more with. And also when we get research from you guys, to echo something Sven said, you know, in his keynote, if your research ends up giving a technique that can plug in and solve a part of my system, that's easier to integrate and to test out and do, as opposed to something that needs to change all the assumptions of the system, right? Those are hard.
Mm-hmm.
Change a part, that's easy.
Very good. So let's continue here. And so this is for Mark. You mentioned application in support of research for time series. So you mentioned a little bit, the question was, what are the synergies between your research and Henny's research to forecasting workloads, and also which tests to run in low test environments?
So the first part, I hope at least is easy. So but basically, what we've seen, the networks are able to do really good is generalize the workload, right? And so basically what you can do there is, if you look at the underlying data that Henning used, you can then say, okay, we don't have a lot of data in this specific class. Can we enhance that in some way, right? So then you can generate more data. And we've also seen it in practical applications that the performance of the prediction increases, if even by a bit, but it still increases because you simply have more data and it's a more generalized version of the data. So this helps, first of all. And second, you can use this also in another way that you say, as I mentioned, so maybe not only the University of Prague, but I mean, let's face it, students, I mean, we all are not really snowflakes, so students behave in a similar way everywhere. And we say maybe some other university would like to share its data, but again, it's still student data and it's subject to, you know, some restrictions. But if we're able to produce synthetic data that represents and mimics those students, we can again have a better generalized version of the data, and again increase, you know, this workload and you know, representation and of course also the prediction in a sense. I'm not sure that I follow the question of identifying load tests. Can you elaborate on that?
Yeah, because if you know which operations are, so the workload is a set of operations and a set of the probability of occurrence. If you look at an operational profile view, right? And that could translate also on what are the most important load tests to execute, right? So it's, so what are the most impacting operations, right? So it's it's a relationship between workload analysis and load test identification, right? So this is the research that I've been involved with, right, with my group. Yeah.
So again, I think this is, if I understand it right, it ties into David's question in terms of basically, once we know what the input data is, then we can ideally, of course, tie it into the output workload if we are in a more or less isolated environment. Because if, and I think this is beautiful because we were also researching that, and David talked about it, you know, the strange things that once you landed on an AWS server and it's not up to you to decide where you land and what's happening there. So, right, so maybe you have some parameters which are external and you cannot map them. So of course you would need to, you know, this is something, of course, that you can remove by generalizing the workload, some noises like that. But once you know more, of course, about your input pattern, you could ideally at least find some causalities between that. But this goes out of the scope of the, let's say, domain independence of the data synthesis. Here, you would need, at least in my opinion, some kind of domain knowledge to bridge that, right? So you would need to have at least some knowledge of the data and of the system that you're testing to do that, right? But if you're only looking at, for example, a database system, then it's totally viable in my opinion.
Okay, so I just got the message here from the chairs. They're telling us time is slipping through our fingers. So I'd like to thank everyone. It was a great session, great presentations. Thanks for the presenters and for the people that participated. Thank you very much.
Thank you.
Thank you.
Dissertation award. I want to say just a couple of words about this award, and then we'll hand over to SPEC President David Reiner, who is going to announce the award winners. And then we'll have a presentation by the award winner. So the Dixit Award is named after the long-term SPEC president, Cavalier Dixit. It was established in 2011 by the SPEC Research Group. SPEC Research Group is an organization within SPEC. You'll hear more about it tomorrow. We have a presentation on SPEC in tomorrow's sessions. And this award aims to recognize doctoral dissertations in the field of computer benchmarking, performance evaluation, and experimental system analysis. Quite a broad scope. The terms, the evaluation criteria are the scientific originality, scientific significance, but also equally important, the practical relevance, impact, and quality of the presentation. So this is quite a broad set of criteria, and this makes the award difficult to win. If you look at the past winners, you'll see also excellent dissertations that were proposed, but could not make it to win the award because, for example, they were very good in terms of scientific impact, but no industrial impact, and others the other way around. So this award really looks for something that is strong from a scientific perspective, but also strong from an industrial impact perspective. Very difficult challenge to meet. The award itself has had already these winners. You can find on the website a mixture of different topics here from different areas, but of course most of them very closely following the general focus of the SPEC Research Group, as I mentioned in the previous slide. And I want to stress it's not only about benchmarking. You might think SPEC is only benchmarking. This is much more than just classical benchmarking. It's about quantitative system evaluation. It's about empirical methods and so forth, but also resource management. So this is quite a broad scope covered here in this award. Very prestigious award. We have had strong competition. Normally up to 15 nominations were made. It varies from year to year, of course. So it's quite difficult to actually win this award. So now I want to introduce SPEC President David Reiner and hand over to him, who is going to make the official announcement of the winner for this year. And he will then hand over to the winner to present his work. David?
Okay, thanks a lot, Sam. It's a pleasure to be with you all today. As Sam mentioned, this award is in honor of Cavalier Dixit, who was SPEC's first and longtime and very loved president who passed in 2004. And I think Cavalier would be happy today to see his name associated with honoring this academic excellence. The winning dissertation, Models and Simulation of Blockchain Systems, was authored by Mayor Al Irby from the Newcastle University under the supervision of Professor Ad van Moorsel. The selection committee was especially impressed by the potential impact of the work, the rigor of the quantitative evaluations, the balance struck between design, development, and evaluation, and the variety of publications associated with Dr. Alderby's dissertation. Congratulations, Mayor, on this significant accomplishment.
So this is...
That's the second one, yeah, I guess.
I had to skip because they were the other way around, but anyway, this is the winner.
So this is the winner, yeah, congratulations, Mayor.
Congratulations also from my side, Mayor. It's a huge achievement.
And before we... Yes, yeah, congratulations. Before we go to his presentation, given the high quality of nominated dissertations, the committee decided to also recognize the runner-up dissertation entitled Performance Modeling of Distributed Stream Processing Topologies, authored by Thomas Cooper, also of Newcastle University. Under the supervision of Dr. Paul Eliz-Shelvin, members of this committee were impressed by the industrial relevance of the application scenario, the sophistication of the modeling employed, and the exquisite, well-articulated writing in the dissertation. Congratulations, Thomas, on this accomplishment.
Congratulations also from my side. So now we move to presentation by Meir. So I will stop sharing. He will briefly present a summary of his work, and then we can have also questions. So let me stop sharing. Thank you very much, David.
Thank you, Sam.
Meir, can you share? Ah, great.
Yes, hello everyone. This is Maher Al-Harbi, and currently I'm an assistant professor at Taiba University in Saudi Arabia. I did finish my PhD program from Newcastle University last August. Today I'd like to briefly present the main contribution of my research. My PhD titled Models and Simulation of Blockchain Systems. The main motivation from this work is behind the technology of blockchain and smart contract technologies, as they have gained a lot of attention recently. In the literature, there are a large number of proposed blockchain systems, such as Bitcoin and Ethereum, each of which with its own design decisions. The challenge is how to investigate the different implementations and design choices of blockchain systems. A simple approach is to rely on experimentation or trial and error. However, this approach is not feasible or practical on blockchain systems or on existing blockchain systems, because either you need to interrupt the real existing system, or you need to have control over the system. For that, simulation models emerge as an excellent solution to study blockchain systems. From our reading in the literature, there are some attempts to utilize simulation models to study specific aspects of blockchain systems. However, there is no general purpose tool that can be used to simulate blockchain systems. For that, the main aim of this research is to bridge this gap by proposing and developing a general purpose, flexible, extensible, and widely usable simulation tool for blockchain systems that can be used to analyze different performance problems and different blockchain systems. The main 5 contributions of this research are depicted in this figure. The core contribution is a block simulator. This is a simulator that is intended to simulate different blockchain implementation and to study different performance problems. The intended users of the simulators can be blockchain designers, analysts, or researchers who want to explore different blockchain systems and different performance problems. Also, another contribution of this research is a systematic mapping study that we conduct to explore the current research on smart contracts technology. And based from this systematic study, we at least identified 2 performance problems related to the Ethereum smart contracts, which are the verifier's dilemma study and the profit uncertainty studies. We note that both studies are of interest in their own to analyze and to propose solutions to mitigate their implications, but also this can demonstrate the usefulness and the applicability of the proposed simulator. An important things to conduct simulation studies in general is how to feed the simulator with real data in order to draw realistic simulation results. And for that, to conduct the two performance studies, we collected the data from the Ethereum network. In particular, we collected over 300,000 real transactions data. And then we conduct an extensive analysis to estimate the distributions for these or for this data by relying on statistics and machine learning techniques. The fitted distributions are then integrated into the simulator in order to generate representative transactions for these case studies. Here is just a list of the 5 main contributions that we accomplished in this research. And each of these contributions have already been published in international conferences and journals. Due to the time limitations, we will go through them very quickly. The first main contribution is a systematic mapping study that we conduct to explore the current research on blockchain-based smart contract. And from the mapping study, we provide a survey of the scientific literature. We also identify academic research trends and uptake, and identify gaps for further research. And also from this mapping study, we identify the 2 case studies for the simulators, which are presented in point number 4 and 5. The second and main contribution of this research is a generic blockchain simulation tool that we named BlockSim. BlockSim is meant to be flexible enough to support the analysis of a large number of blockchains and to support a wide range of performance analysis problems. BlockSim covers different blockchain layers, such as a network layer and consensus layer, incentives layers, and also provide simulation constructs that are intuitive, hide unnecessary details, and provide and extensible. At the core of BlockSim is a base model that can be extended to support the implementation of any blockchain system of interest. BlockSim is implemented in Python, and it's validated against real life systems such as Bitcoin and Ethereum, and measurements study from the literature. And it is available online on GitHub, and you can find the link in the PhD research. The third contribution is an extensive analysis to estimate the distributions for Ethereum smart contract transactions. And as I said earlier, this is to feed the simulator with real data or with representative data in order to conduct the studies we have in this research. And for the analysis, we use correlation analysis. Also, we use statistics and machine learning techniques to conduct such evaluation. The fourth contribution is an extensive analysis of the Ethereum verifier's dilemma and the proposal of 2 solutions to mitigate its implications. Briefly, the verifier's dilemma is that miners in Ethereum are not well encouraged to do the verification process, and they might behave dishonestly by skipping the verification process in order to maximize their income. And for that, we analyzed how these problems can impact the system, especially when the system grows in terms of the block size. And also we proposed 2 solutions, parallel verification of transactions and active injection of invalid blocks. And these 2 solutions, we show through simulation that they can, they can eliminate the risk or the advantage that miner would gain from skipping the verification process. And as that, we proposed those solutions to the Ethereum community. The fifth contribution is an extensive analysis of the impact of the uncertainty miner perceives in Ethereum when selecting transactions. And this is a problem is that miners, when selecting transactions, they do not know exactly how much they will gain from each selected transactions. And for that, we run the simulation since we collected real data about transactions. And we analyzed through different strategies how miners could be impacted by this uncertainty, and also how to solve this uncertainty. And to solve this uncertainty is to have a fair system that always give rewards for miners based on the computational efforts each transaction can consume. And this is actually problems, and both these performance problems can be really critical, especially when the Ethereum network grows in terms of the block limit. And here is the main publications that form this PhD research. We have 7 publications that try to capture the content of this PhD research. In addition, we have other publications that are not part of my PhD research, but they are very related to the work that I did in my PhD. The first type of work is about performance benchmarking of Ethereum smart contract transactions. In particular, we measure the computational efforts for each individual operation code in the Ethereum virtual machine. And we compare the computational effort with the award that miner would gain for executing such opcodes. And the second type of work is the proposal of a consensus mechanisms for the appendable blockchain systems. The appendable blockchain system is independent system, is different from the Bitcoin and the Ethereum systems, where this is in the context of IoTs, where each device can have a block, and each time a device send data, the data will goes to its block. So we just proposed a consensus algorithms in order to improve the performance of such systems. And here is the end of my presentation, and thank you for your attention and for your time. And I'd like to thanks from the heart, from my heart, the organization of this award and the committee for their time and for their efforts. And I'm very happy to receive any questions, or if anyone have any question about my work or the simulator that we have, you are most welcome to contact me at any time.
Thank you very much, Maher.
Thank you.
So any questions? I did not notice in Slack, but just speak up if you have questions. I have a couple of questions.
Yeah, sure.
So I was wondering what particular metrics you are targeting in the simulation. I mean, as a result of the simulation, you want to report certain metrics. And the second related question is, how do you specify the workload? You have to abstract the workload, and the workload in terms of, on the one hand, the payload of what you put in that blockchain is an important aspect, of course. And then on the other hand, of course, the request profile. I mean, what kind of transactions do you have? How frequent are they placed? These are important aspects of the workload.
Yeah, thank you. This is a good question that we cover in the chapter related to the simulator. For the metrics, we mostly this simulator is a performance-based simulators. So it covers like the block generation rate, how many blocks can be generated in the times. What about like the latency for transactions, the throughput for transactions, also the incentives for miners, since miners, they put some efforts, they participate in the mining process. So the simulator can report how much reward they can get by the end of the simulation time. And in terms of the loads, these are configurations that can be set in the simulator. So we have like a configuration file where you can set all the parameters that needed for how many blocks can be generated, or how many transactions can be generated per second, and how many miners do we have, and the hash rates for all miners, and what type of consensus mechanisms are you using, proof of work or different consensus mechanisms. Also, we have currently we have until now we have 4 models. The first model is the base model that is containing just the main construct, so you can extend it as you need. And also we have the Bitcoin model, so you can just choose the Bitcoin model and simulate the Bitcoin. And we have also the Ethereum model. Ethereum and Bitcoin are very related to each other, only some differences related to the gas model and incentive models. And also we have the appendable blockchain model that we just added to the simulator.
So I assume you have some notion of resource demands in terms of how much resources different parts of the operations consume. So these resource demands are probably extracted from some traces you have from real life observations. So my question is, in what sense can you claim that your simulator is a generic simulator doing blockchain simulation versus a simulator representing specific implementation of blockchain where you have some specific resource demands observed?
Yeah, this is a good question. Yeah, for that we have a base model. That base model just contains the main constructs that are common to every blockchain systems. Like every blockchain system has blocks, has transactions, has nodes, and also has a peer-to-peer network, and have consensus protocols. So these are the main elements that we identified to be common in every blockchain systems. So that we build the simulator based on that. And then we just create different models to use the base model and to add different layers or to add different things to the simulators.
Did you develop this simulator from scratch, or did you use some simulation framework?
Yeah, this is a good question. Also, at the beginning we were about to use a framework. Then we just opt for a generic programming language, which is Python. That can give us more flexibility. I mean, in terms of how to model and how to simulate the simulators. So we just use Python in general. But in the future, we might extend, some frameworks, like there are some simulation frameworks for Python. So we might include them in the future to help us in terms of statistics and event management and stuff like that.
And final question, is your implementation open source?
Yes, it is open source, and it's already on GitHub. And I'm very happy to, if anyone use the simulator or extend the simulator, or if anyone has any question, I would be very happy.
Great. I know several people working in similar direction, so I will point them to your work so they might contact you. There are also activities in direction of more modeling, using queuing models, for example. They try to abstract at a higher level, which is a different approach, but I find it very interesting. So I would definitely look at it and also forward to potential interested people.
Thank you so
Any
much.
questions, further questions? I hear none, so thank you very much, Maher, and congratulations again. All the best for the further steps of your career. We wish you further great success in the next steps. And thank you very much for presenting your work today.
Thank you so much. Thank you for this.
So we have about 3 minutes before the next session starts, which is going to be the work in progress track. And Klaus Lange is going to chair that session. So a short break, and then we continue in this room. Thank you very much.
Norbert, you going first? Are you prepared? Are you there? Can you hear me?
Yes, hi, I can hear you.
Excellent.
I'm ready.
Okay. Ian Dang, you too? You made it. Can you hear me?
Yes, I'm also ready.
Excellent. Awesome. Jörg, how are you?
Yes, I'm here.
Excellent. And Alexandre? Mr. Bergel? I saw you. You cannot hide.
I was just speaking to him on Slack, so he should be around.
We just get him into the chat.
Yeah.
Alexandre, you unmute. Can you unmute and just saying hello, making sure that the audio works?
Hi, does it work?
Yeah, now it works. Thank you.
Okay, excellent.
Okay, good. You have another 2 minutes and then we will start with Norbert.
Video also works, right?
Yes. Video works, I see you. I recognize you from the video yesterday. Excellent. And who's sharing right now? That is Maha. Maha, can you unshare? Stop sharing. Thank you. Appreciate it. Okay. Okie dokie. Hello, everyone, and welcome to ICPE 2021 session 2. We already had a great keynote speak from Sven April and an awesome first session on testing, measuring, and profiling. Also, congratulations to my heart for this year's Cavalier-Dixon laureate. Absolute fantastic work. Now let us start with session 2 with 4 interesting work in progress and vision paper. Each presentation will be around 5 minutes. After 3 minutes, you will hear a little gong. Just time check for the presenter. That will follow by around 2-minute Q&A session. Maybe we're stressing the time a little bit. See what we can do. First up is Norbert Schmidt, and Norbert will present towards a benchmark for software resource efficiency.
Just sharing my screen.
Please go ahead. Not yet.
Give me a second here.
Now we can. Please go ahead.
Okay, great. Yeah, hi. I will be presenting our vision paper about software resource efficiency benchmark that I authored together with my co-authors from the Red Hat company from Munich, Richard Vogel and Andreas Brunert, and my supervisor, Professor Kunev. So why do we think we need a software resource efficiency benchmark? It's very easy. No? Next, why is the slide not going forward? Okay, because, well, in our opinion, if you can reduce the resource amount that a software needs in a data center, it will relate to the energy consumption. And as we all know, there is an increasing load on data centers, and already they consume about 263 terawatt hours of energy every year, and it's even estimated to rise further to over 1 petawatt hour until 2030. And this directly relates to the resources that will be used in the data center by the software that is deployed there. So we came up with the idea for software resource efficiency benchmark, and we tried to have 3 main goals that we want to achieve with this benchmark. Is first of all, we need an understanding of how the resource consumption of a software in a data center actually comes together, how it works. And software vendors that write this software should get an understanding of this. The second goal is that the buyers that actually go to the vendors and buy their software, they should be able to compare the software from different vendors according to how efficient the software uses the resources that are available. And our third goal is that we want to spark a competition between software vendors to make their software more resource efficient. Something like a public database where you can look up. So we already thought about how we want to do that. First, we want to collaboratively develop abstract description formats like a workload description, execution environment, and how the output of the benchmark will look like. This needs to be done collaboratively with a lot of people from academia and also industry to come up with a good and sound format. The next step is to derive software-specific formats for benchmarking, and by software specific I mean for a specific software type, like enterprise resource planning software or other types of software. So for a group of software that does the same functionality, but differs in implementation. And as a third step, the vendors need to provide instances of these descriptions for their specific software. And this will go into the technical part of the benchmark, which we plan on building a prototype for, which the main part is the execution engine or the benchmark controller that controls how the benchmarks run, that set up the cloud environment, everything, and controls the run of the measurement. Monitoring data will be gathered through a measurement adapter that collects all the data from the different toolings, sends it back to the execution engine, which produces the resource demand description instance and sends it to a central storage repository on a publicly available web server, so everybody can go and compare their software resource demand to hopefully achieve better resource efficiency. And we found 3 important challenges that we need to overcome. The first challenge is that we need a description format for the resource demand of the software. And there's currently no accepted standard to express the resource demand of software. They are resource profile, but they are dependent on the workload. The second challenge, also very important, is how to specify and standardize these workloads, because these benchmark results should be comparable among each other, though we need a standardized workloads. And we cannot achieve that without the help of industry and academia to arrive at a standardized workload for a specific software type. And the third challenge is less a technical challenge, more how can we get people to use the benchmark? How can we increase awareness about resource efficiency and energy efficiency? And how can we increase the acceptance of such a benchmark? And we plan to collaborate for this challenge as well. So what we want to do in our next step is, first, as I mentioned it quite often, to foster collaboration between different groups. We want to present our progress on this benchmarks on the prototype and our standardization on workshops and conferences to get feedback from the performance community and energy efficiency community. And we want to work together with Spec RG Power to get also contact to industry. And we want to begin work on a usable prototype. That means we already evaluated already available formats that we might leverage for this. We're currently in the middle of this. And we want to define a use case to showcase that our prototypes has the functionality that we want. So, thank you for your attention. So if you have any questions, feel free to ask.
Yeah, we have now the open for question on Slack or the chat. Quite frankly, I would like to go first. You talked about some limitations there. Do you think you covered in your paper all the limitations? And quite frankly, do you have plans how you overcome those?
Yeah, in the paper we mentioned some limitations. Let me skip to that slide. very quickly. We have three main limitations that we identified. That is, first of all, the abstraction from hardware. Very difficult. We cannot rule out the hardware completely. Maybe it's not entirely possible, but we need to abstract as much as possible. And that's a very difficult, very technical task. We have not looked into it that much how we can achieve that, but this is something we need to overcome, but also are limited by. Also, the impact of the resource efficiency on operational costs. We're not aiming to reduce the operational cost as such, because even if the software itself is resource efficient for the task it does, if you deploy it badly in a wrong way, you still cannot guarantee that the software will run efficiently. That's some limitations that we have. Also, we cannot take into account every custom-built software artifact or customer-specific feature that they demanded specifically for themselves and was implemented only for this customer. So we will focus on a more broader set of standard software, like I mentioned, enterprise resource planning software, which is currently we're talking about as our main use case for this type of benchmark for our prototype as well.
Okay, Norbert, we are at the allotted time. There's several questions in the chat. I will put them in the Slack in a moment. Or Alexander, if you can put them in the Slack, and then we can, if you wouldn't mind, to answer those so that we can go back to them. Thank you very much. I appreciate it.
Thank you.
Then the next one up, please stop sharing. Ian Dong, he will talk about the empirical evaluation of video conference systems and the use in industry, academia, and entertainment. Go ahead. He cannot hear you.
I'm sorry. Thank you very much. Hello, everyone. My name is Ian Dan Chang. I'm a master's student in computer science at the Vrije Universiteit of Amsterdam, and I'm here to present the work that my colleagues and I have conducted. We have created a method to measure the performance of online video conferencing systems such as Zoom, Discord, and Microsoft Teams, and implemented it as an automated tool. We think this is important because since COVID-19 has impacted society, we've seen a lot more meetings been turned online. So these been taking place online using these systems. Using the bit.ly link at the bottom, you can see our article. So this is EEVCS. Millions of people rely on these systems every day for their work and education, but we don't completely understand how the system work and which ones we should be using. The main problem that we encountered is that there's not enough information about the performance of these systems during usage. So we're talking about CPU usage and bandwidth usage, for instance. If we had this information, we could make an informed decision on which system better fits our needs. Therefore, we decided to conduct experiments on Zoom, Microsoft Teams, and Discord. Our main contribution is that we conducted real-world experiments observing system and application level metrics of video conferencing systems. Our method considers various communication channels such as audio, video, and audio and video, different network types, so Ethernet, Wi-Fi 4, Wi-Fi 5, and 4G LTE, and different experiment sizes, so one-to-one and an entire classroom. The method consists of different clients over the network, where one is also running the measuring tool. The metrics that we capture are CPU utilization, network bandwidth, and the number of packets and packet sizes sent and received. Here we see a box plot of the resource consumption of the video conferencing systems, and we capture this by average number of CPU cores used. Discord is open source video conferencing system, the only one in our test, and but they have significantly higher resource consumption compared to Zoom and Microsoft Teams. So if an alternative exists, we suggest that using Discord is not a great idea. So if you have Zoom or Microsoft Teams as an option with regards to resource consumption, this would be a better idea. Here we see a real-world scenario, the largest in our test, which was a lecture at the Vrije Universiteit. Here we compare a one-on-one call so like a video conference call, and also a classroom environment where there's a professor sharing the screen and some participants with video. What we gather is that increasing the number of participants and video streams introduces high performance variability. The presence of performance variability is not good news for our ability to deliver courses online, or for the idea that we might have students engage visually in the classroom. Furthermore, we've also have some interesting findings. First one is using wireless connections leads to much higher performance variability than if we use a wire connection. So if you use a wired connection, you would experience way less performance variability versus Wi-Fi 4 or any other Wi-Fi really, or 4G. And also in specific settings, Microsoft Teams consumes less bandwidth than its competitors. So if you share the same network with your family and both of you need to do work online, it might be a useful tool to use. Thank you very much for your attention, and I'm open for questions. Also, the bit.ly link for the article is EVCS.
Excellent, thank you very much. Question for Alexandra is, if you had around 6 to 9 more months on this project, what would you do? What is your goals you would have with that, and what is an outcome you would like to see out of your research?
Okay, well, currently we only focus on the client side because this is what we have access to. So we're only measuring what the client sees. Maybe if we had more time and resources, we could see what happens on the server side, and maybe get more insight into that.
Okie dokie. There's some comments about what kind of great work you did. Also, that is really useful. Not much more of a question, but really useful information you're providing there. And I would go. Another question from Manoj. Why do you think wireless connections have more variability than wireless?
Why do I think wireless
more than wireless? I think wired.
Yeah, I understood the question. I guess because yeah, with a wired connection, you have the best possible network bandwidth at all times, is what I would think is the reason.
Okay.
I also see a question about the behavior during the test, so the quality. We did not track quality during our test, so it's just the stream that we got at that time.
And Clark, there's a question about, do you expect to try Big Blue Button?
Sorry, can you repeat the question?
Do you expect to try Big Blue Button?
So as another video conference assistant?
I would assume yes. Yeah.
Yes, we could use it as a future work, as another one we can add to the test or to the experiments.
Okie dokie. And then Alexandra, I didn't understand your question. Please add as Qt2 where X is a count of movements like heck. Okay. Okie dokie. There was one last question from Andrew Bondi. To clarify, do you mean Wi-Fi for wireless, or is that a GSM network?
No. No, it's just a wireless. So it's just over a wireless Wi-Fi connection. Yes.
Okie dokie. Thank you very much. Awesome work. I really enjoyed reading it, and I hope you have time and effort to move on with that. Thank you very much. So now we're going to the next paper, next version. That is work is done by Jörg Domanschka, and to talk about Buzzy. Please go ahead.
I guess that's me.
Yes, I hope I pronounced your name right.
Almost, but never mind. Yeah, you should be able to see my screen now or within seconds, I guess. Okay, cool. So thanks for being here, for listening to the vision that I do have together with some colleagues from Ulm University and from the University of Würzburg. Buzzy is our attempt to improve DBMS benchmarking by providing representative synthetic workloads. So what's the basic idea behind that? If you look into benchmarking, the reasons why we do that, we could coarsely distinguish between two reasons. The one is what I call vendor-centric, where you want to understand how your system, as a vendor, how your system would compare to other systems. And for that purpose, you usually fall back to standardized, also synthetic benchmarks, but standardized benchmarks. From a client perspective, once you bought a system, that's not really what you're interested in anymore. So how you compare to others, but rather you would be interested in whether the performance you get from the system that you have is actually fitting the workload that, you're seeing. And in order to tailor your system to the workload, you have basically two options. The first one is to replay real-world traces you would get from a production system with the limitations that there's no variation in the data set that you have, the usual limited lengths and scope. And the second option is you fall back to the standardized benchmarks that also the vendors would use, and you try to map the workload that you're seeing to those standardized benchmarks. So you have to get an understanding of all the possible benchmarks, and you have to understanding of the workload, and you have to have enough skills to do a sound mapping from one to the other. And what Buzzy is trying to do is aiming at is to do this mapping, but without all the hassle. And basically, we still want to get traces from a production system, but instead of throwing these against the system under test and then tweaking the system under test as long as it's perfect, we do cluster the traces and then synthesize more traces from the observed traces. And finally, in the final step, we recompose the synthetic traces and only throw them to the system under test. And by doing that, we hope that we're able to realistically emulate production workload, but still be tailored to individual systems. And as a bonus, we also get the possibility to run what-if scenarios. What would happen if the number of users increases by 10 in the last few months? Would my system still be able to handle that? Not very surprisingly, the steps that we require for that are 4 of them. So we have a pre-processing phase, a synthesis phase, and a composition and benchmarking phase. Just very briefly, because of the limited time in the pre-processing, we would rather, deal with cleaning the data and do some clustering. We saw that also this afternoon, that clustering is really important. Forgot to remove that. In the synthesis step, we then take the clusters and enhance the data set that we have. So we create more data on a per cluster basis, and the generated data hopefully looks similar to the original data, but not identical. If you saw Mark's presentation earlier today, it's a very similar approach, but we're not only dealing with time series here. Furthermore, we'd like to enhance the synthetic data with anomalies, so we can introduce anomalies that we've not seen in the traces, just to see if the system still works, if things go wrong or there is some unexpected load. And finally, we plan to exploit Mark's approach here to use neural networks for the synthesis step, just because it has worked very well in other domains as well. In the final step, there's the composition part. As I said, you can do a, say, as-is composition where you just recompose the individual clusters as you saw them in the traces, but you can also recompose them differently to do this what-if analysis. And finally, of course, you throw the synthetic traces against the system under test. We only started recently with that work, so we're currently looking for real-world traces, but despite that, we already did create some traces that we are currently just replaying, so we have the benchmarking in place, and we're playing with different approaches to clustering into synthesis currently. And further down the road, we will need to look into even more approaches to synthesis, to the anomaly enhancement and the composition. And thanks for bringing it up, David, earlier. A solid validation methodology for that approach is a really important thing we will need to work on. So, concluding, if you're owning a DBMS workload trace, or able to generate such a trace, or working on similar matters, or have any questions, then please get in touch with us.
Okay, excellent. Thank you very much, Jörg. We are open now for questions. When you talk now about workload traces, actually, quite frankly, I work for Hewlett Packard Enterprise, and we have traces we have the permission to share. And maybe afterwards we can get together and talk about that, because that sounds pretty awesome, interesting for me, what you're doing there. And then we maybe can do something about it. Or contact me afterwards, and we do.
That I will definitely do. Sure. Okay. Thank you.
And yeah, when we're preparing traces for folks, they're of course anonymized and all that, so that we can share that on. We get all the permissions in, so that there's no problems to share them for research purposes.
Okay, that would be really cool. Thanks.
Okay. David, you had some challenge. You talked about some challenges. Is your question in the chat and Slack? Is that answered at this point, or you want?
Well, you may have finished answering it by giving them some traces. It's just, you know, you did talk about a little bit, but just the bootstrapping of like, this is wonderful because wonderful idea because it's so hard to get traces, but it's hard to validate because it's so hard to get traces, and about how to get started there. And so we did have some discussion there. I have some thoughts I'll take offline also, but you know, thanks for the discussion. And yeah.
Okay, cool.
Thanks, David. Okie dokie. I think at this point we're going to the next presentation. Thank you very much, and
thank you.
We're looking forward to work with you. So the next one is presented by Alexandre Bergel, and about optimization of virtual Java virtual machine flags using featured model and genetic algorithm. Thank you. Go ahead.
Hey, hello. My name is Alexandre Bergel, and this is the result of the work with Geoffrey and Felipe from the University of Chile. So work is about automatically improving the performance of a Java application by automatically tuning the Java virtual machine. So the Java virtual machine is actually a pretty complex piece of software. This is the layer between the operating system and the Java application. So as soon as you want to run a Java application, you need the JVM to run on top of it. So the JVM can be pretty difficult to configure and to tune and to optimize. So here, this is an example of the flags that need to be provided to the JVM for an optimal execution of the Minecraft server. And yeah, so this is a complex one. And the author of this Minecraft server said it took weeks to identify those, to find those options. And there are many reasons why it is difficult to actually come up with a good configuration. First, some of the flags, they need some arguments, but the official documentation about the JVM do not say much about which kind of arguments you need to provide. There are some documentation, and you can also look at the source code, and basically they said, this, for example, G1 new size percent require an integer as an argument, but which value is reasonable here? I mean, there is really not much documentation about that. And also, some of these options, they do interact with each other. And for example, all those G1 options here that make sense only if the G1 garbage collector is enabled. So if you do not put these options here, those options or flags do not have any, are meaningless. But so even though this is rather clear for the G1, you need to set the G1 compiler garbage collector in order to have to configure it. It could be very obscure for some non-obvious flags. And so there are 528 different flags in the latest JVM, which is a lot. And tuning those JVM for particular configuration is absolutely it's very difficult, as this example here shows. So our short paper is about automatically tuning the Java app to improve execution time without any knowledge about the Java application. So the idea is to search for adequate flags and their parameters. So we use a feature model of the flags to express constraints between a group of flags, and we use a genetic algorithm to search for an optimal configuration. So using the genetic algorithm, so this is a very convenient algorithm that we are using here, easy to implement, easy to understand, and it really maps what nature as brothers. Like you have to, if in a place, in a physical place, you have rabbits and wolves, then only the very fast rabbits will have a chance to survive. And this is exactly the same thing here, where each blue dot here is a configuration, a random configuration at first. And those configurations that get selected, because you might have some good configuration that really decrease the execution times of the benchmark. And then those configurations that get combined in order to produce new member of the population. And then we do some iteration, and then at some point we end up with an optimal or a good, at least a good configuration. So the flow of our work is the following. So first we took all the list of the flags. We took the list of the flags that the latest GVM accepts, and we look at the official documentation. And as I said, many of those flags are poorly documented. So we looked on forums for each of these flags, and we also look at the source code of the virtual machine. Then with all this manual search, we were able to build a feature model in the sense of the software product lines. And this feature model is able to express constraints among different group of options. Then we took some benchmarks, and we feed the feature model and the benchmark to the genetic algorithm, and then we end up with some optimal execution, optimal flags to minimize the execution times of the benchmarks. And for now, we are only focusing on DACAPO and the garbage collector flags. So here, this is the feature model we have. So it's pretty standard notation we're using. And our result for some of the benchmarks, the one that actually makes sense in our case, we have seen some significant improvement. And to make sure that those improvements, that range from 1% to 23%, to make sure that those improvements are not just the result of some noises, we run some statistical tests, and it does make sense in our case. So we have found some significant improvement without any knowledge of the application. And yes, so this is my presentation. So thank you very much.
Okay, thank you, Alexandre. There's a question from Jesse. How do you think the always online and varying over time workload of online games affect the way we can evaluate the effect of configuration parameters on performance?
Oh, sorry.
Pretty much when you look at online gaming, there's the variation in the workload change over time, and it's always online. How would you implement that with your solution? How would that affect it?
Okay, so we haven't directly deal with the Minecraft server. I mean, that was just a motivating example. But in the case that I would do with the Minecraft server, basically would be like by having some by building a benchmark myself, which basically like sending a set of representative HTTP requests, I guess, on the server. But yeah, so basically, I mean, we need a benchmark that is reproducible and can be repeated many times and give stable results.
Okay, awesome. And one last question from me, because in my role as Power Committee Chair, we're creating benchmarks, energy efficiency benchmarks, and you have a large community there. You have AMD, Dell, Fujitsu, HPE, IBM, Intel, and Microsoft there. We're working on these benchmarks, and we're working currently on a new version. And I would be really interested in seeing your environment really figuring out for a specific configuration to get the best Java flags going. Maybe something we should look into it, because I think that would be absolutely fantastic if you can automate that.
Exactly. I mean, that would be interesting. So far, we just used DACAPO because for some reason it was the simplest to execute, the simplest to process. But yeah, it would be good to look at other benchmarks.
Okay, there are several more questions in the chat and in Slack as well. I will move them over there, and then please take a look and address them.
Yeah, I will. Thank you very much.
Now, thank you, and then thanks again to all the participants and the authors. I really appreciate it. Congratulations for being here, and you guys have a great day. I really appreciate it. Bye-bye.
There is a steering committee meeting in 15 minutes or even 10 minutes now. And if you're interested to participate, you should contact corporally at the link. It will not be in the same Zoom room. So this Zoom room will close, except if some of you want to continue discussing together.